Okay, here we go. Welcome to the June installment of the Forth 2020 user group meeting. First set of talks is going to be the continuation of the elevator challenge. That was already a blast last time round, and I'm sure we'll see more interesting solutions later on, followed by a coffee break and individual presentations whose list I promptly replaced. Facebook to me. Oh, come on.
Excellent, excellent.
Good.
Thank you very much, Cornelius, for the host for being our host today.
Recording is in progress, so yeah, let's show off.
Our first participant for the elevator challenge, Peter Jakacki, will come a little late, but he will join us for sure. And our first participant from the elevator challenge was Greg Schmidt. Greg, can you show us what you did? Is Greg in the meeting?
Yes, he is.
I cannot hear him. You need to unmute, please.
He is unmuted. Maybe audio is not working.
We cannot listen to you, Greg. Something in your setup. If Greg has an audio problem, we can jump to the next one and then come back to Greg. Atle is also in the list of presenters. Do you want to show us what you did, Atle? And later we show Greg's solution.
Yes, well, mine is very short, so yeah, I can do that. Let me just move things around on my screen a little bit, and then I will try to share two windows at the same time. And I will try to point I did a little addition. It's pointing at the ESP32 super expander. And now I will share. Let's see how that goes. I think advanced portion of screen. And how do I select my portion of screen again?
Basically, it gives you a list of windows or the whole screen. By default, it is the whole screen.
Yes, but that's going to be too much. I'm gonna try to share a portion of the screen. I did it here the other day. So advanced portion of screen. I just need to come on, and maybe I can select now like this. Oh, do you see a portion of my screen now? Does anybody see a portion of my screen? No.
I see your board, Atle.
Yeah,
I see your web feed.
And that's all. Okay. Yeah. Well, then I'm gonna give up on that and rather just show one. I'll show one after the other. I think that's the best way to do this. So first, I'm gonna share my source. So I have one value for the floor that the elevator is on, then one for the number of floors, and one for the direction it's going, because I need to know if it's going up or down. And then I have some buttons, one to go up and one to go down for each floor, and one set of buttons for the elevator. Then I have some words. The ones with the question marks is to find out, am I going up, am I going down, etc. And so the real meat is down here. Here I know if I must go down. I must go down if there are no buttons above, but if there are buttons below, then I go down. Must go up if there are buttons above, and I'm on my way up. And what else is there that I could show here? Well, I added a little thing to. I have also want to print the lift so you can see the lift, and then I have some test cases here. So for example, I press the floor buttons 4, 6, and 7 inside the elevator. I press the up button on the 5th floor and the 3rd floor, etc. So it should be relatively easy to understand. Now I can take this code here and I can copy it, and then I can go and share my run screen. Now let's see. So I share the other one. I should be able to share both at the same time, but it doesn't seem to work. And now let me make this a little bit smaller and wider, like this. Now you should see a prompt, right?
Yes.
You should see a, yeah.
Yeah.
Okay, so I paste my code in here. And now let's, yeah, okay. We'll just go and follow what has been happening here because it goes quite fast. So it's pressing these buttons, 4, 6, and 7, and then we see the elevator go up or down. So where the stars are is where the buttons are pressed, and on the floors you see whether it's the up or the down button that's pressed. So it goes up and down like this. But let's do it slowly. Let's go and press. See here. Here, let's. Now I have an interesting bug. Oh dear! Now I have a horrible bug here. Okay, I need to restart this. Hold on just for a moment, because it seemed to have crashed. Ah, that's all right. Yeah, I'll stop sharing. I'll restart my ESP32Forth and go again. It's running over a telnet connection. And I just added, so let's see. Let's try this again. Yeah, you can probably see this board reacting to the code that I'm uploading. And now I can share. So let's try again. So let's press some buttons. So now we've pressed some buttons. Inside the elevator, we've pressed buttons 4, 6, and 7. And on the 3rd and 5th floor, we have pressed the up button. Now we can run this. I'll give it 10 iterations. That should be enough. And you should be able to see the buttons come, the lights inside the elevator. They should come alive here on the ESP32 board. So you see it's going up and down, and you'll it's waiting a little at that's probably what happened the last time. It wasn't a bug, it was just taking its time because it was going too fast. So now it's going through, and you can see the elevator is this star here. That's the elevator. So it's now currently stopped on the 5th floor, which is this LED. And that's basically it. That's all she wrote. I can do it one more time with some other buttons. So now I've pressed the down button on the 4th, yeah, with my spelling, 5th and 6th floor. And let's run this. Oh, another bug. Okay. Yes, of course. It's not happy about Telnet unless I do this. For some reason, it's something with the carriage return and line feed. I don't know why it's doing that. Well, let's give it 4 iterations. Huh?
This is Don. Try using real
Yeah.
term.
Well, and all I have is Telnet, and it's going all right. I just need to type return a couple of times for it to, I don't know, go through. I don't know. There's it wants line-oriented protocol. It cannot do character at the time. But here you see it. We can print the lift using this, and we can go up 1 floor and print the lift. So that should move this star up 1 floor. We can go down. These are the primitives that I'm using. So now we've gone down 2 floors, and that's basically how it works. So inside this run, this run word that I have, I can go back to the code. Let's see. Go back to where's my code again here? And you see the run word here. If I were to make expansions to this, then I would scan for elevator buttons and so on in this part here. So what I'm doing here is I'm turning off the LED for the current floor. Then I'm going 1 floor. And when I go 1 floor, I'm checking whether I must go up and down and if there's somebody waiting, etc. And then I print the lift so you can see it in that black screen that you can't see anymore. And then I turn the LED on for the floor that I'm on now. And then I wait for 200 milliseconds. So this would be where the extensions to the system would go. And that's what I had for the elevator challenge. It wasn't much, but at least I got it to work.
That's very nice. Great.
Well, thank you.
Amazing, fantastic, Atle.
It's newbie friendly.
Who else is the next one? Is it ready, Atle, or we continue?
Can you hear me now?
That's all I had.
Can everyone hear me?
Yes, Greg. Then
Oh, great.
a big applause to Atle. And now Greg Schmidt.
Okay. Sorry about the problem. I switched to a different headset and it created some problems for me. But it sounds like everybody can hear me now. Okay, let me go ahead and share. Can everybody see that?
Yeah.
Okay.
Perfect.
Just a brief intro on the Forth that I'm using. This is a Forth that I wrote sometime in the mid 2000s called Forth Script, and this is the documentation for it. It was really intended to work in conjunction with a game system for defining and playing two-player abstract strategy games. And that's this site here. It's something called Zillions of Games. Let me just briefly mention what this is. This isn't the topic of this presentation, and if there's interest, I can do another presentation for this. But what this is it's a system for defining board games, especially abstract strategy games, which involve no luck, although some of these games can roll dice and so forth. But it has a built-in Lisp interpreter, and it's an extensible package. And somewhere around the mid 2000s, I created an extension called Axiom, which you can see here, which uses Forth, which replaces the Lisp with a Forth system called Forth Script, which was what I just showed you. And if you want to download this, I'll put the link in the chat. You click on this Axiom development kit, and it's included there. And if you click on this link here, for axiomatic games, there's about 83 games that have been written in this language in the Forth extension that I created. Probably most of these are mine, but not all of them. So a number of people have sort of jumped on board. But, you know, this is an old package. People are still developing games for it, but, you know, this goes back to the late 90s when this was created. But anyway, I just wanted to give you that background. So I'm using Forth Script for the elevator challenge. And okay, let me close this. What I wanted to show you first is I have a little README file that describes how this works. I know that elevator control can get very sophisticated. And I'm sure many of the participants implemented, you know, interesting and maybe complex algorithms. I went to the other extreme. I wanted to see what is the simplest possible program I could write that would solve this or that would qualify for this challenge. And it ended up, there are 4 user-facing words here. There's reset, which basically resets the elevator and puts everything to the first floor. Display
Greg,
just yes.
Greg, can you give us a larger characters?
Oh,
Like 14 or 16 point.
Yes. Let's go with. How's that?
Oops,
Is that a little better?
That
okay.
would
Let's
be
go full
smaller.
screen. Okay, so these 4 words, reset basically resets the elevator, puts it on the first floor, and clears any pending calls. So a call would be either a call from a floor where you're requesting the elevator externally, or an internal call where you're inside the elevator and you select a floor button, and that's what this call is. It accepts a floor number. So to call floor 5, you would just say 5 call. Display just shows you the current state of the elevator. It shows you the floor that you're on and the remaining floors that are pending. And run just basically advances to the next state. So it basically causes the elevator to move in whatever direction it needs to. Now, I did just some brief research on how elevators work, and one very simple common algorithm that seems to be used is move up until, as long as you have floors above you, just keep moving up. And then when there's no floors above you, move down. So that's essentially what this does. And then there's an internal, I'll say kernel or system words, and there's really just a few of them. So I can determine if there are floor requests above me, above the current floor that I'm currently on, requests below. I can ask, should I stop here? And I can ask if we're idle. And that's really about it. So here's a sample session is you say run, and it's telling you that since by default we're at reset, it says we have no floor requests. We're currently at floor 1. We'll call floors 3 and 7 and then just keep pressing run, and it just shows you, it tells you what floor you're currently at and what it's moved to. So it performs an action. So we moved from floor 1 to floor 2, and we still have pending requests to floors 3 and 7 above us. So we're moving up. And then we reach floor 3, and we only have floor 7 being requested. And now somebody calls for floor 2. We do the run, and we move up to floor 7 because, as I said, we're always moving up when there's pending floors above us. And then now we're moving down to floor 2. And then finally, there's no pending requests, and then issued 2 requests, one for floor 6 and one for floor 1. And as you can see, we're just doing the same thing. We're moving up to 6, and then that gets cleared, and now we're moving down to 1, and then that gets cleared. I just wanted to show you the code next real quick, just to show you what that looks like. And let me change the font. Okay. So we have really just 2 variables, the current floor number that we're on and floor requests. So floor request is a bit mask. And why did I use a bit mask? The reason I did that, so basically bit 0 means I'm at floor 1, and bit 7 means I'm at floor 8. If those are set, and of course you can set, each call sets the corresponding bit into floor requests. And what the consequence of making it a bit mask is if I can easily ask if I have any floors above me or below me. So let's say that bit 2 is set, indicating that I'm at floor 3. All I have to do to determine if there are floors below me is subtract 1 from that. And that basically turns on all the bits below me because it's a power of 2, right? And then I can AND that result with the floor request. And if that is true, then I have floors pending below me and I need to move down. If I want to know if there are floors above me, I just do that same thing, and I invert that mask, and that tells me, that sets all the bits in the floors above me, and I AND that with current floor requests, and that tells me if I'm going up. So the run basically just says, okay, display the current state. Okay, we save the current floor we're at because we're going to clear it later down here. We ask, are there requests above me? And if so, I just move up 1 floor. So I just increment, this just increments the floor number. That's all that does. Otherwise, if there's requests below me, we decrement the floor number and we do the display of our current state. And if we're at a floor that is requested, we'll stop here, and then we'll clear the floor request when we're done, and that's it. So this is the code. It's, I don't know, maybe about a page and a half with comments. So this seemed to me like the minimal program I could possibly write to solve this problem. So if there aren't any questions, that is pretty much it.
I just want to make a comment. That is very clean code. I really like the way you did that. Your run command to me is perfect, factoring and creating the language to apply to your application. So great stuff.
Well, thank you. I mean, I've said this before, that I look at Forth as a nice vehicle for creating a domain-specific language, and basically, right, you create a toolkit for managing elevators, and hopefully, if I were to extend this someday, it would lend itself to that. But at any rate, so that's it. Thank you.
Cool. That was a very nice presentation. So, this being said, who's next? Atle, weird. James Norris in here. Let me see. Greg, could you unshare your screen, please?
I've been looking for the button, and
the
window got minimized, and it's not so obvious where it is.
Been there, done that.
Oh boy.
You should, this is a Windows box, right?
Yes,
you should have a little taskbar floating there somewhere that has the unshare screen. So wide green bar telling you that you're screen sharing, and to the right of that, the smaller reddish field that says stop sharing.
I apologize, but I am not seeing that. In fact, maybe the thing to do, oh wait, screen sharing controls. There we go.
Yeah, you can also use Alt-Tab in Windows to tab through stuff to find hidden windows.
I don't.
Okay, wait, I have it. Here we go.
Okay.
I found it. Found the admin option.
The override. Thank you.
Yeah, that.
I was about to just leave the meeting and
so
then rejoin.
No, that's shall we not? Good. Where did I have my overview of? Okay, we had Greg, Atle, James Norris in here. Where's my overview of participants?
Cornelius, we can call Pablo, or we can call, let me see here the program. I have a video from Bill Ragsdale and James Norris. I don't know who wants to present. I have 4 of you. I can, Pablo, are you in the meeting?
Yes, Peter, here.
Do you want to present now or later, Pablo?
Later.
Later, okay. And then I show the video of Bill Ragsdale. Let me share my screen. Now I'm sharing. Let me tell me if the sound is okay.
No sound.
There is no sound.
No sound.
No sound. Could that be that it's sharing the screen, but the video is still tied to your microphone? Because if that's the case, and we can't make this work fast, then we might want to put this online with the recording of this session.
When you click on the showing your screen at the bottom right, there is something that says set sound or optimize sound. You have to push the second button.
Oh, I found it.
Oh, good.
No, I don't have it. I don't have it. I will present a video of Bill later. And we have other people here. I don't know if is James Norris in the meeting?
Yes, he is.
If he wants to present the Diaperglu solution, then I can set up my settings for Bill's video.
Sure, I can do that.
Amazing.
How do
Go
I?
ahead.
Oh, there it is. Share screen, right?
Yep.
Okay. Go. It's not going. There it is. Can everybody see it?
Yeah, but I can't read it because the font is too small.
Okay. Yeah, I think that's as big as it's going to get. This is the elevator over here. Font too small. Hang on 1 second. Okay, how do you change the font style on this?
Try Mac. Okay, this is Windows. You could go into the screen properties and say.
No, it's. I mean, anybody know CSS?
On the browser, could you do an increase the magnification on the browser?
Yeah,
With
hold your two fingers.
Alt 1, 2, 3 or something, Alt 1, Alt 2, and so on, or Alt plus.
Give me
If I remember correctly,
one.
Alt 0 brings you back to the original magnification.
All right, I'll skip trying to do it that way. Alt,
It's
what is it?
possible also to make the window really small and share only the window.
All that.
Okay, like that would probably work better. Oh, there it is.
In the browser, why don't you try
How do you
Control+?
stop sharing the screen? Oh, I found it. Okay, so try that again, and then this time.
In most browsers, if you do Control+, you will increase the font size, and if you do Control-, you'll make it smaller. That works in most browsers.
Control, not Alt. Good
Oh,
morning.
this is too big.
Oh, I didn't do it yet.
Looks promising.
Yep, getting there.
How's that?
You can well do it smaller. I mean,
Now
put
we
more
only
on
see
the
part
screen.
of the screen. That's
Yeah,
better.
yeah, that's good.
Okay, well, I guess I can do that. Okay, that's the elevator. Oh, and I had a song for this. So like, let's say you, I'm gonna make it do it this way. Okay, I'll make that, let's do that. So in other words, it covers all the cases now. So you got like salespeople press the button. Yep, and it dings. Door opens, it only gets the up person. And let's say that guy wants to go to the 6th floor. Picked up that guy, dropped that guy off. Dropped that guy off, picked up that guy. Let's say that guy wants to go to the 5th floor. And then pick that guy up. Let's say that guy wants to go to the 0th floor. That's it. Oh, speed of fourth, power of fourth. Stopping all the bugs that blunder forth. It's Diaperglu. Okay. Okay, any questions? In other words, it's the same as last time, except now it covers all the cases. I put the ding in, it opens the door. It has 3 movement modes. You can just jump to the floor. It'll go floor by floor. It will skip stopping at floors once you pass the destination. That's the express mode. You can change the number of floors up to 60. You can make it do multiple steps between floors, so you won't be able to see it, but it'll just count until it does like 5 steps between the floors. That's pretty much it. I didn't do the 2 elevator case, but I think I know how to do it, except I can't count the people.
Can you review the source code, or you did that last time and so nobody wants to see?
Oh, did I redo the source code?
No, I did. Can you review it?
Oh, review it. Oh, you want to see it? All right. That's what was open before. Okay, this is the CGI script for it. To make it a little wider. Okay. It's a Forth script. It loads the Forth program that controls the elevator, and all this does is generate an HTML web page. So it gets the variables from the CGI script, looks like from the time before, what its state was, all the state variables that you passed from the web page. So the browser will pass form variables to the CGI script. That's this part. Then it draws the web page, which is just HTML. So what I was going to try and do to make the font bigger was change this line. There's a way, I'd have to look it up. There's a way to set the font in CGI. I mean, with an HTML page, you can use CSS to set the font size. And I have the note somewhere on how to do that, but I don't remember how to do it off the top of my head. And that's just the web page, and all it does is submit forms with the variables. The elevator code is in elevator code is here. And this code is separate. You can probably use it in your Forths. I tried to stick to standard Forth stuff, not any Diaperglu specific words, except for the bit manipulation words. I put the buttons into a 64-bit variable, so you need a 64-bit Forth. And then I used bit scanning things, because there's hardware in this x86 to scan for the highest set bit and the lowest set bit, and I use those. And my Forth has a way to just access them. I use those to find which button to go to. And that's what this stuff is. That's all the code right here for controlling the elevator. You probably can't see it. And then the rules that it follows are documented down here. So there's the, here you go, that's the license. Where put the rules. And this is the text, the English of what it's doing. All the rules for that the elevator follows. And I'm pretty sure it's correct. You might need to see that. Any other questions?
Very, very cool. I just have a request. When you guys finish this elevator thing, can everybody upload their source code to the files section for people to learn Forth coding?
Sure, no problem. It's already, it's on my website hidden, so you can do it that way right now, but I will copy it and post it to the group's website. And I'm going to stop the share unless anyone has anything else they want to see. Oh, so I think, Don, you're the guy that brought this up, that Forth's strength is its ability to rapidly develop bug-free code. That's kind of what I was doing with Diaperglu. So Diaperglu has all these runtime error checking in it to find bugs, including the CGI mode. So it was very easy for me to find out when I made a big mistake. So it would tell me what I did, and I didn't have to spend 3 days trying to figure out what the mistake was. This is also the test script that I use. It tests all this. It's only not for the CGI one. This tests the elevator state running. And I tested every case pretty much that it could happen. And I made sure it did what I wanted it to do for everything. So it only gets the button for the direction it's traveling. It'll turn around if both buttons are set and the guy that gets in the elevator doesn't press the higher button, like if it's going up. I made sure it did all those cases, and then I tested them. And that's all the tests that it does. And if I change anything and run the test script again, it'll tell me whether I broke anything. And that's the key to why I was able to do it so fast. And any other questions before that? Oh, looks like you're sharing there, Don. Oh, no, it's on yours. I get it. No other questions? Okay.
Excellent, James. Fantastic. Then the next one.
A+ for Spain.
I don't have the sound of Bill adjust. I will try. Let me try if I can share.
I just wanted to comment real quick that I'm glad I wasn't the only one that chose to use a bit mask to represent the floors. Seemed to have some nice advantages.
Well, good morning, good afternoon, good evening, depending on your time zone. By way of introduction, I'm Bill Ragsdale. I'm the founding president of the Forth Interest Group back in 1969, but let's not dwell on ancient history. Let's get on to the project for today, which is one solution to the elevator problem. And here we go. I think this was an outstanding problem, rather difficult, rather involved, but with a logic that everyone can understand. So as I viewed the problem, I broke it into several steps, design elements, if you will. The first step was to create a visual model for an elevator, or if you wish, a lift. The building has 10 floors, which I've numbered from ground and then 2 through 10. The elevator has the capacity for 5 passengers at the same time. And here is a very important element. 70% of all elevator activity is either to or from the ground floor. That is, most of the traffic people have to be at the ground floor and go up to a room. Once they're in a room, they come down to the ground floor. So I've allocated 35% of all traffic from the ground floor up, 35% of the traffic from the ground floor down, and 30% of the traffic or floor to floor. The elevator will only stop at the floors with down passengers when going down, and conversely, the passenger action time is 1 second. This just allows us enough time to see the operation dynamically, and the travel time between floors is 1 second. My first element on the program was to lay out the building and an array which shows all the passengers. So I have a 5x10 array which shows each passenger slot available on each floor, and then of course all 10 floors. On the right-hand side, we see the square brackets show the elevator. The elevator currently is on the ground floor, and inside are 5 dots, which shows the elevator has a capacity for 5 passengers. The square brackets all the way up show the doors are closed. Here's a quick look at the actual program in use. We'll come back to this at the very end. You can see it again, but I wanted you to see how the elevator system is working so that when we come to each component, it will be recognizable. So the elevator currently is going down and it's full. 5 G's in the elevator, they will unload 1, 2, 3, 4, 5. And you notice as each person or each ground floor call leaves, another passenger is added into the building. But again, following that probability distribution. So the elevator is now moving up. It's dropping off a passenger on the 3rd floor. It's picking up the 4th floor call. At the 4th floor, the passenger debarks, but the calls are 2 and ground down, which are skipped. Continues upward now to, I believe, the 9th floor. There it picks up a ground floor call and a 6th floor call. Comes down to the 7th floor, picks up a call, goes to the 6th floor and does a drop. Skips the 5th floor. On the 3rd floor, 4th floor, it picks up 2 passengers. On the 3rd floor, it will pick up 1 passenger, but it skips 1 passenger because the elevator is at capacity. Now it's back at the ground floor, everybody out. All 5 have left. It will pick up 2, 6, and 7 calls and a 9, and back up we go. So here's how it's put together. Here's the driving program. As you can imagine, it's a begin again loop. So this runs indefinitely until we do a program break. Well, now within it, we have 2 different loops. We have an upgoing loop and a downgoing loop. So first, we need to find the lowest action floor and position the elevator there. And of course, at the start of the program, this is the ground floor. Then we have another begin while loop. So we determine what floor needs service. We then go to that floor. We process the exits, load up calls, and repeat. So this will repeat the elevator going up, up, up. As long as up service is needed, it will go to the particular floor, and the up service may be to let someone off or let someone on. Once all the up calls are taken care of, now we find the highest action floor on the upside, and we begin this process again the same way in reverse. We found the down service needed, we move to that floor, process exits, and load exits first, and then load the down calls. And now we're at the bottom again. We'll go all the way to the top again and repeat the program over and over. These are the components. This is written in pseudocode. It's a little hard to follow what the physical code looks like. So in this case, we're trying to find the lowest action floor. And this is a do loop over all of the floors, starting from the bottom to the top. And we check the call at the lowest floor that has a call. And if so, we mark that call and leave. Mark it means put it onto the stack for the next program component to use. After then, when this a similar word is used for the highest action floor, when we're at the upper part of the elevator, this would scan all the floors going down. Once we have a service request, that is, we have someone in the elevator, this will process the exits. So if we go to a given floor First, we check to make sure that there's enough space to receive this, the people on the floor. Now, the floor has 5 slots. The elevator has 5 slots. So we never should have an overload condition, because if we have 5 on the elevator and 5 exits, there is capacity for them equal. This is the code that takes us to a particular floor. In this case, we know the floor from is the floor the elevator is on. The floor 2 is the one that has had some sort of a call. If they are equal, in other words, if the call is on the floor we're at, this is skipped because it has no meaning. And so if the 2 floor is higher than the from floor, we move to a higher floor. Otherwise, we move to a lower floor. So this is bidirectional. It will find the nearest floor that needs service. If we desire to move to an upper floor, first thing we're going to do is we show show less than bracket greater than actually shows the elevator door in motion. Then we do the I show square bracket pause. That closes the elevator doors. And then the I1 plus show with the less than bracket greater than pause shows the elevator in motion. This loop goes tick, 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 floor by floor, closing the door we're on, showing the elevator in motion to the next floor. And it will go until we reach a floor with action, which another word takes over. Generate the calls. Every time someone gets off the elevator, we generate a random call so that there will always be 10 active passengers in the building. The up arrow floor generates a random number, floor number from 0 through 9. This purposely skips the ground floor. That's handled separately. So this will handle calls 0 through 9 on a random basis. To find 2 floors call going up, we do a begin up floor, and then the comparison and repeat. So this will find 2 floors call going floor to floor, but it will eliminate duplicates because there's no point in having a call to and from the same floor. This actually creates a trip, and here's where the proportioning is done. The 100 random proportion less than selects a probability between 0 and 69. And in that case, it assigns the floors involving a G, involving a ground floor. If for the remaining 30%, the else upper pair executes, and this then uses the upper pair word to do an assignment floor to floor. So the key part on proportioning is this created trip. It's the one that allocates the major traffic from the ground floor up and the major floors down. The digital components, this is what we see when the elevator is moving. The dot square bracket shows the closed doors. Now this elevator greater than XY go to, this positions the elevator at the proper floor and the proper position on the screen. And then the dot quote simply prints the closed elevator doors. It took a fair amount of work to work out keeping the building static in the same coordinates and having all the scrolling screen be at the bottom. This shows the elevator in motion, which is the dot with the less than bracket greater than. That's an elevator in motion. And again, the elevator greater than go to XY positions at the particular floor. And we just write ASCII text with the elevator door shown in motion. And finally, the elevator, when static, with showing the riders internally. In this case, the dot quote left square bracket quote simply puts on the screen the left-hand door. The do loop in the middle puts out the 5 dots, or if they're passengers, the dot symbol puts out the passenger number. So in this case, again, the do loop shows either dots or passenger numbers. And then we close the line off with the dot quote with the right square bracket, the right-hand door. Here's how we display the building. To put the elevator with open doors at a given position, We then do .elevator. This takes us to the particular position. So as the doors open with all the little dots. The building itself is shown here. The do loop begins on the ground floor with the I dot floor. And when I is 0, you'll get a G. And when I is not G, you'll get the actual floor number. And then the I dot brackets prints out the rest of the dots on that floor. And finally, 0 elevator puts the elevator off the ground floor. So we'll see now our dynamic again. In this case, the elevator is on the 6th floor. It's picked up passengers to the 3rd and 4th floor. 4th floor, it drops the passenger. Picks up a ground floor call. On the 3rd floor, it drops the passenger. It picks up 2 calls, but it leaves 1 behind because the elevator is at capacity. It skips the 2nd floor, come to the ground floor, everybody out. All 5 out. And of course, remember, we're adding new passengers as we go. It will load up the 3rd floor call, goes up to the 3rd floor, drops the 3rd floor passenger, picks up the 4th floor call. Now it'll go all the way up to, goes up to the 4th floor and drops the passenger, and now goes all the way up to the 9th floor because everything else is down calls. On the 9th floor, we load up 2. On the 7th floor, we load up 2. On the 6th floor, we drop a 6. On the 2nd floor, we pick up the 6 and 2 ground floor calls. Now the elevator is loaded, so it continues down to the 2nd floor, drops a passenger, picks up 1, ground floor, everybody out. Once the elevator is empty, we'll now pick up 2 2s, a 6, a 7, and a 9. So the elevator is full and away we go again. So there is a summary of our operation. The problem at the beginning had the 6-step problem statement, which formed the very direct elements that form the program. Basically, every line in that statement translated into a couple of Forth words. This took a significant amount of effort, more work than I actually thought. It took about 12 hours to put together. I thought originally it would be like 1 to 2 hours, and I would just crank it out. But it did get quite involved. I learned about programming graphics on a scrolling screen, how to freeze part of the screen and have the rest of the screen scroll. And I find that 10 active passengers in the building tends to overwhelm the elevator. At the beginning, there were 5 passengers distributed to the building, or 10 passengers distributed to the building. And then as we would load and unload, we always kept a number of 10 passengers in operation. This shows that a capacity of 5 on the elevator is probably a little bit too low for this building. There were a number of cases where passengers had to wait, and so one could extend it further to do some wait times and passenger loading to figure out, do we need a bigger elevator? In summary, I rewrote the program 3 times, each time adding to it, and of course, going back and rewriting some of the lower levels. The first pass was just a simple simulation of getting the building, the elevator, and the data arrayed. The second pass here was getting the elevator motion and floor going properly. And then the third, that was the most complex, was controlling the pickup and the drop-offs so that we had the proper logic between activity on the way up and the way down. So I'd like to thank the folks for the chance to present today. This was a very interesting program, and I really enjoyed presenting to it, and thank you for the opportunity. And now we will go back to our fearless leader. This is Bill Ragsdale saying goodbye.
That was very cool.
While I have the floor, I'd like to answer Klaus Schleissiek's question. Is that okay?
Good.
Good. I guess it is okay. When I did the Fig Forth model in 1969, I added the compiler security, which is putting parameters on to check the pairing of conditionals. And I think that was the first time it was used. There was a little bit of grumbling because it wasn't pure the way that it had been done by Chuck, but it added a convenience and security. Another innovation was that the word names were variable length. Up till that time, Chuck had words specified by their a number and 3 letters, the length of the word, and then the first 3 letters. But you could have a conflict like a word like look and loop would come about with the same 3 LOO. So I put in a length variable so you could select the number of letters you want in the word, anywhere from 3 to 31. So, and everybody then immediately set everything to 31. So we went to full length letters. There was a few other innovations like having a shift variable, so you could compile code in uppercase or lowercase or mixed case. Up till that time, I think everything compiled to uppercase. So a number of those old chestnuts from FigForth have been carried through into Forth ever since then. You had a question about unstructured conditionals. That can be handled. As Klaus said, it shouldn't be done, but it can be done because at compile time, you can put on square brackets and you can swap the parameters, the compiling parameters, so you can set up unstructured code. In my memory bank, I think I've done that maybe twice in the last 30 years. Possible, but certainly not necessary. So thank you very much. Back to Peter.
I see a Greg has raised a hand. Greg, please go ahead.
Yeah, a question for Bill. With the begin and end checking, is that something that is possible to turn on only during program development and then turn off later for production? The reason I ask is it seems like if that's the case, then I don't see how anyone could really, complain about it, essentially.
That was on the compiler security, turning off the compiler security.
Yes, right.
With all humility, I'm saying, give me a break. This is only occurs at compile time, and it involves execution of 1 or 2 words. So it's trivial in time, and it's invisible to the user. And the compiler security is not in effect at runtime. It's only in effect compile time.
I thought that was the objection to it, was that there was a runtime cost. So
no runtime cost.
If there's no runtime cost, then it seems perfectly fine to me. I have no comment then.
It's really helpful because if you do nesting, like putting a case statement inside a do loop, it keeps you out of trouble. If you leave a word out, if you just leave like an if out of a case statement, you miss 1 word, compiler security will catch it. You'll catch your syntax error. It keeps us out of a lot of trouble.
Yeah, I thought
the biggest objection, I believe, was that using check digits is pussy programming, sort of. Not serious. A man wouldn't need that.
Go. Well, I chuckle. I think you'll find the dominant number of Forth systems use compiler checking.
Yeah, Bill, the point I wanted to make, and then after I used this, since I implemented FigForth, I always used it. And then a couple of years later, it finally occurred to me that you can do more with it by building more intelligent structures, because the receiving word can look at it and do choices, do different things depending on what check digit is on the stack, And as I said, you can throw away the again because the repeat will know whether there was a while or not.
Good. Great, very good.
I have a raised hand from Jim.
I don't know if you were asking about Diaperglu's runtime checking. If you were, there is a no Diaperglu mode, which eliminates most of the runtime checks, and it does run faster. So if people don't like the checking, I use the runtime check mode for most of the development, and then when I get done and I know that it works, and I want it to be fast, I use the no runtime check version of Diaperglu.
That was really the gist of my question. I mean, I think, checking array bounds is a very common example, right?
Yeah, it does that. It does all of that. Overdoes it, I guess.
Yeah, I agree. I have a matrix package, and I do runtime checking on the matrix package because it's a mix between integer and floating point, and then especially array bounds. So
we need to move on.
Discreetly, you can use runtime checking, and the speed of the computers these days is so dramatic. Using Win32.Forth, I've done 100,000 scans, and it takes a couple tenths of a second. So execution time is trivial.
Perfect. We need to move on, gentlemen.
Yeah.
Next participant, Travis Bemann. Travis, are you in the meeting?
He is. Go ahead.
Hello.
Hey. Travis, your turn.
Yes, I'm presenting right now.
We don't have a camera. You are, there he is. There you are. Never mind. All good.
Okay. Here is my implementation, which is big, overgrown, and overly complex of the elevator thing. Basically, partially for its complexity is it's designed as an object-oriented, multitask system where there is one task. Well, they're not tasks because everything runs within a single task, but uses asynchronous programming to have multiple entities that send messages to one another and which keep their own state. And of course, I had to add accessor methods just because, even though it is completely unnecessary. Like, one thing here we have is the display. And the display receives messages stating the current state of the system, and it uses ANSI terminal codes to control the drawing. Then we have controller class, which handles the going up and down and determining what direction to go at any given time. And then we have the have a task that all it does is send messages saying once every blue moon it updates the display, updates the system. And then we have another one which goes and handles input from the user. And then we have one that just a class that encapsulates everything and sets up the system. So here I'm going to quit. Now I don't remember. Let's go to 2D. Okay, this is not behaving right. Reboot. Okay, gonna connect. I don't know what was going on there. Okay. Now I'm going to go and upload my code over the USB. Now I'm gonna set it to use 9 floors. And I'm gonna, let's say, when I do it, user wants to go up on floor to floor 4. So I'm gonna do 4U. Now another user wants to go up to floor 8. But the user that was on floor 4 wants to go down to floor 3. And now there's a user that wants to go down on floor 2. You know, the user on, well, basically, this one isn't automated. It's designed to have messages from the user on the console to tell it what to do. And basically, the whole thing is, as you can tell, big and overcomplicated. And it's one key thing about its design is it's designed into, let's say if I do go down, have user down for 3, then up is on 4, 5, up to 4, 5, up on 4, 5, I should say, ignores that and then comes back and does it. And the one key thing about its design is that each, not task, I call them actions, that makes it up does not share any state. Rather, there's a state class which copies of the class are sent between each individual action, indicating the current state, which is the floor count, which is just to avoid making a global variable for that. The current floor, whether it's between floors, whether the door is open, and the current elevator direction, and also flags for each floor which the floor flags are 3 bits. Bit 0 is up, bit 0 down, and bit 2 is whether the user wants to stop on that floor. And I could probably go on and on, but that's about it.
Cool. Thank you so much. Who else?
Before we move on, can I make a comment?
Brief,
Sure.
please.
Travis, that was a lot of work, and I really appreciate you showing us object-oriented programming. I'd like to point out how much more difficult and complicated it was than using structured programming. And most of the software today is using object-oriented programming, C++. So I thought that was a great lesson for us, Travis. And wow, that's a lot of work.
Yeah, I decided I made a previous version of this that wasn't designed in such a fashion and was significantly smaller. One thing about it though is that a lot of that bulk was just accessors. Like, you know how in Java programming you have get and set and get and set and get and set all over the place? That's a lot of what that was, just because I had drunk in the object-oriented Kool-Aid. And
I think that was a tremendous lesson, and I really appreciate all that work.
really, the reason why I did it the way I did was as an experiment in separating out the different parts of it as much as possible, so that wasn't just one program that did everything as a whole, which is what my previous version was. Rather, one part handled displaying to the user, another part handled input from the user, another part clocked every second where it would update the display, and another one would handle the actual decision making.
Nice. This looked good. Gut. Who's next? Pablo. How does it look
Yes,
like?
here.
Ah,
Yes.
good. You're good to go.
Yes.
Okay. All yours. Take it from here.
See my screen?
Yep, all good.
Well, first to all, I need explain the difference in between R3 and 4 for understand the program. First, in R3, I not have access to compiler. No compiler time for the programmer. No create do's and things like that. I have no state. The numbers has a prefix for different base. I have no access to dictionary. And for them, I need the word for control flow need stay in the base word. Another thing, I need or I add the explicit address for variables, and the internal takes from colorful ideas. but with modification. In the language, the prefix of the word act like color in color form. For example, the pipe define a comment in the code. The include is made with I don't remember. The caret define include to the code. The quote define a string. The colon define code, and double colon define exported code. I don't remember is this character define data or variable, and again double hashtag is exported data. And this is important, the simple quote define or explain the address of a word. And this is the prefix for hexa, binary, decimal, and fixed point number. Then the control flow is made with block code, enclosed in parentheses, and need a conditional word. Is 0, is not 0, is minnow, the top of stack, of course. And have two types of control flow. If when the conditional is prior the block code, and while when the conditional is in the block code. And the program starts in the colon alone, not like prefix. The last, the memory difference are, I define a variable, and the number or the numbers following the name put these values in memory, and the var indicate this place in memory. And then if I see the name of the variable, this put the value of this variable, and when use the prefix single quote, I put the address of this variable. In normal Forth, this not work like here. Then here, comma and this class of word are in reference to free memory, no dictionary. And I have two registers, A and B, for memory work, for get values and store values. Well, the program. This is the lift changer. I start explaining from the boot, the program to the simple part. This is the initialization of graphic window. This initialization of GUI. This is a sprite for drawing sprite in screen. This file is here. It's an animation of a guy walking. a control of time, I initialize here some array for use like object for a instance of the guys and the place in every flow. And this work make a loop refreshing the screen. This work is here. This is the main loop. Clear screen, initialize the GUI, draw the building, run the elevator, calc time for animation and this like this, draw every sprite, sort for not draw wrong order, draw the GUI and redraw the screen. If in a state automatic, send guys to the floor and a key for controlling the program. Escape for exit, shoot F1 and F2 for make random thing. Send a guy in a random floor and restart the random generator. For example, automatic, here the definition of automatic, when the variable out mode is on or is off, then don't make nothing. And every interval send a new guy. Here a if operator. This is the GUI window. If active, if not active, do nothing. This select color, and this is a button. This is the draw of every button of floor for every flow. When action, when push the button, yes. This is the debug mode when shows some variable. This is a slider for the interval of sending guys to the floor, and this is a statistical variable. This is the drawing of the building. Only select color and drawing rectangles. Yes. And the elevator and the guys are in state machines. The more this is how add a guy to the game. This behavior to the list the persons with these parameters. These parameters store, for example, the position, the velocity, the number of sprite, the floor when draw, one state, a codification of animation, and the time is passed from the build of the guy. This is how draw every guy. If have an state, execute this state, I can indicate the state of the guy. For example, waiting for the elevator, in elevator, and out for elevator to street or whatever. If in the debug mode is active, then shows some information, and this take from memory with the register A, take from memory the parameter for draw the sprite. Okay, the XE, the number of sprite. This is as the add the velocity to the position for animator. Here the word for the Wejgaard info. This is the word for the animation. And this is the state of the guy. Here when walking to elevator, the logic for walking to elevator. This is the logic for sorry. This is when the guy go to elevator. This is when the guy wait in the quake of elevator. This is the operation to wait for the elevator and advance when the guy in front of the guy take the elevator and advance in the quake. This is the guy in the elevator. And this is what to exit. They are three draw of person for this is three variable when the draw the graphic for every type of person, and this is the perhaps this is interesting. For example, when I go to elevator and get in the quake waiting for the elevator, this is the condition for I am now waiting. Then this change the state of the guy. I store in this guy. Now I am waiting. This will wait is here. Yeah, and waiting when I can upload to elevator, I change the state to ahora now in the elevator, and this is the state of the guy in the elevator, and when out from elevator, change the state here, and walking to exit. When return 0, remove from the sprite drawing in the screen. This is the sprite of guy and elevator. They are one. This is a string for show the state of the elevator. Run the elevator, take the variable state, and execute the word depend of the state with this, and the state of the elevators are idle, waiting, run, open, close, open door, close door, and broke. I add but not use. Open and close is the time when the door are open and door are closed, and well, run is moving to a floor. White is waiting for waiting for a button, and irle I don't remember who made this, but anyway, there I word for look for a floor for go, and the information of buttons are stored using this word, push a button or push a button in the elevator, and this control the keyword of the floor. Every guy have a portion of memory with the information for every guy, and this is the word for access to this information for every guy. How store the button in the elevator, and the end. This is all. This is the working. This is the working program. Here, not in automatic, then with F1 send guys, or I can click a button, or put in automatic and define the millisecond for send guys, very fast or very slow, and show me the bug information. The last I do is the control of the quake in the floor, and need see in what position, if every guy, the capacity of the elevator is 3, and I can remove the debug information, and this is draw for the key. And that's all. Thank you. Any question?
Fantastic, Pablo. Very well. Nice.
Yeah. Excellent animations.
That looked great. That looked really great.
Yeah, I like they are actually walking and not just sliding around. It's very nice.
Pablo is a professor for kids, teacher now, and he teaches programming, assembly, and a lot of graphics. These are 3 is for graphics, and young programmers make always this kind of games. He has different games activities, and one of these days he told me he can show us a class with his students.
Yes. I need to I need to convince.
Yes.
Convince to the voice. I teach programming to kids with make simple games. If you like, in the chat, I show you what games make the kids.
Well, I was calling the group all the time to use the Facebook page and post the pictures, etc. And this generates
the connection between people, and this generates that force is live and active, and that people come to our meetings. If not, it's very difficult for me in the future to create this kind of meetings, because I don't see what people are doing. And I know there are many people doing things in force, but if they don't post, nobody knows. So from time to time, everyone in the group should post at least one in a month, once every week, and so on. Francois, yes, go ahead.
I have a question for Pablo. I went to your GitHub repository and I saw that you are working on the Linux version of R3. How is that coming along?
Yes, the last version of the R3 communicate with the operating system through the dynamic library. And the version is working, but I not add the communication with the calls, for example, for make graphics. And you can download the previous version of R3 who have this access, the R3D4. This is a multi-platform, but the last version is not finished. I only work in Windows. The simple console mode work in Linux, but I now have time to develop this.
That's really too bad, because it would be interesting to do graphics like this easily under Linux as well. But yeah.
I cut the communication. For me, it's very boring. Try to make the language work in every system, because I like to program in Forth, not in the operating system, and then the advance is very slow. In this case, sure it's working, the Linux version, but I have no time to make the interface in between the Linux and the R3. If any can like to add this system interface, I explain how make this. But
I'm interested. I'm interested to see what is to be done.
Okay, well, you can download R3 for the GitHub, and if you execute in Linux, you see a terminal hello.
Right.
And if this work, the system is working, and if you like for email, I explain how to add, for example, SDA library for make graphics.
Right. Okay. We'll be in touch over Facebook or email or both.
Yes.
But
yes.
I'm definitely interested.
Okay.
If I can contribute.
Thank you, Franco.
Can I ask a quick question to Pablo?
Yes.
How long did it take you, do you think, to write your elevator challenge program in R3? Just approximately.
The first version without guys in some hours, but the 3 or 4 days, not all days, some hours in every days, trying different possibility for make these two-state machines working. Very nice to program this interaction. Need rewrite many words because are very complicated. The emergent behavior of the two state machines.
Okay. Yes, it's not an easy problem, but it looks very good. What you've done. What you've done.
No.
What are the two state machines here? Are they the state of the lift and then the state of the people and the requests for the lift?
I don't understand.
You understand? You say there's interaction between two different states machines.
Yes.
What are they? Can you describe them quickly?
When the elevator is in one floor, need take guys from the floor, and need indicate the guy go to the in the elevator, and only the capacity of the elevator, and the rest advance in waiting for the elevator. This indication not easy because where indicate this. I test. I don't remember all the development, but this indication in the ground place make a mess in the behavior of the guys.
Okay.
The guys appear in the elevator in every floor and things like this.
Okay, interesting. Okay, so what we saw when you ran your program was the final result that works. But previously you had lots of fun with little men on the wrong floors doing the wrong things. Must be, yeah.
Yes. And the hard part is the synchronization in the state of those two things.
Yeah. Okay.
Making a game is generally not need this synchronization. They are aliens, there are shooters, but they are not state, are more simple. And
I propose there is a there is a break of 10 minutes or 15 if you like, and if you continue chatting, Howard and Pablo and everyone about this solution of Pablo, it's no problem. But when we are back, we have AxiomForth with Wolf, and I don't want to miss it. It's very interesting for all of us. And then we have, I think, Ulrich also, and who else? Willem. I don't know if Willem is in the meeting. And after Willem, Christian Hinse, who has also a wonderful CNC Quadrature encoder. I am very happy that Christian explains to us. So there is a great program after the coffee. Or you keep chatting, of course. Keep the. It's all right.
I think I need to get a coffee. I'll see you in 10 minutes, guys.
Okay.
Okay.
See you, Cornelius.
See you in 10.
I take a break.
You bet.
Francois, I send me your email and or for Facebook group is the same for help you in the Linux version.
Sure. I'm just saying I will have a look at it and see what options are available, what I can do at this point.
Okay, I speak very bad English, but writing perhaps is better.
It's in the chat.
Okay, yes, I see.
Yeah, maybe we can use something like TCL-TK.
Sorry?
Maybe we can use tools like TCL-TK. It's used for handling graphical user interfaces and things like this.
R3 have an immediate mode GUI. For 4 is spectacular. It's very easy for make a graphic interface.
All right. Well, I'm open to any suggestion, and I have a lot of free time these days on my hands, so this allows me to do some research, digging, and all kinds of experiments.
Okay. I sent an email for make contact.
Pablo, that was a very good presentation. I really liked it. I got up real late, but I went ahead and got on here with the hope I could catch your presentation, knowing that it would have graphics. Unlike a lot of people, alphanumeric graphics, yours would be
Cecile, please speak in the microphone. We can barely hear you.
Oh.
Thank you, Cecil.
Let me say. Is this any better?
Not really.
It's at maximum, but my panel shows that my audio is pretty good, but you guys can't hear me, huh?
It's not a matter of volume. It's as if your microphone was obstructed in some way.
Okay.
Covered.
There's an air conditioner unit right behind me facing the microphone, so it's picking up a lot of noise.
Oh, it's possible that you have something like background noise correction or features like this enabled, and that could interfere.
Yes.
Yeah, it's not perfect, but I can hear you and understand you.
I have a question, if you guys have time.
Is it better now?
Yeah.
Yeah, I turned background noise suppression to the lowest setting. It doesn't allow me to turn it off completely, but I put it on low. So.
Yeah, now we hear your air conditioner, but don't worry about it. Just go ahead and say what you're going to say.
Okay. Well, computers are evil. That's what I always say. And I don't know if you heard me before, but I got up real late this morning, and I went ahead and joined anyway because I wanted to see Pablo's presentation, because I knew he would put graphics in there, real graphics. everything he does with R3. It seems like the main goal is to be able to have graphics in it. Very nice.
So graphics is the key to getting you guys interested.
Yeah, in a way, it's cool. It's amazing what's his name, Greg did with his games. That's impressive. And that's also one way to make Forth popular, I think. At some point, I think Atari had its own Forth implementation through arcade consoles.
We had the Atari guy on the group post about how they used Forth, well, a couple years ago. He said they used Forth to make the games, but not in the games.
Oh, really?
Yeah. So they had a test set up, test bench where they did all their debugging, and that was Forth. And I think they prototyped in Forth, but since Forth was slower, then they had to go back and convert it all to assembly language. Then after a while, they switched over to C. And I forget what he said about how they used Forth after they did that, but they might have still used it for testing.
Are we still recording? Is recording paused?
Yes, it is.
Yes, it is. I can pause this for now if you want to.
Yes, just for 5 minutes.
Okay.
Graphics on ASCII.
Uh-huh.
On a
That
terminal.
that
And
looks cool.
regrettably, he was not here to present today. And next time he will show us.
Oh, good. Because that is something that I'm really interested in. It would make things easy again.
Yes, it makes things easier, and he has a wonderful elevator working with graphics, all in ASCII.
Cool.
So
It's
one
just-
of the things I added to that board back there was a 4-inch touchscreen color display. And so when we get it all working, it would be nice if somebody volunteers to do some graphics programming on it in Forth.
Okay, we continue with next participant, who is Wolf Wejgaard with Holland Force, or sorry, he will present us literate programming in Forth.
Okay. Hi, everybody. And now I will try to pass my desktop. Yes. And the way. Can you see my desktop?
Yes, I can.
Everybody, that's good. Then we have here. It started. I'm programming Forth since 79. And 10 years later, I've finally learned the way to do it. This way. This is what I call literate programming, programming in a book. And if you remember Brody's idea, the composition, structure your application, listening like a book. 84, I read it, and then tried to understand what he meant. But screens are not the smallest unit of our source. So but when I took one word per screen as the smallest unit, then suddenly it worked. And that's what I want to show. Where is it? So I made this. Das Ding da will nicht weg. Here you see already a working my client program at the time imported into the words here and groups and modules. And the word is, I started, it's just a screen. So here there's a space of the screen. And if you have a full screen for your word, you have ample space. So that worked fine. And here are the features you get, and I will not go through them, but show you the later program, a couple of years later, which 1993 is, I hear nothing from you, so it's difficult to hear what's going on. This is what I call literate programming. The book, the words in the module, and I had quite a nice system in it. And you see something, the names have no code. And how can that be? We have a dictionary, but no code. And there, I must tell you again, the other program here, what I did, excuse me, I'm mixed up here. Here is the structure. This part is obvious, this one also, but here we have previous and next word, and a text pointer, that's what you see, divided into, where are we? Can we show it also? It's all a bit. So, and you get the code address in the corner. And the code links, because Roland can substitute code, and if it length is long enough, it's excuse me, it simply substitutes, and otherwise it appends at the end. But the real part here, and that is the thing, the alpha link. So the whole structure has its own link, which connects the words in the browser, but are not related to ja. Wie zeige ich euch das? Kann man das wegnehmen da? I need this. The alpha link connects words independent of code by search, by the compiler, by the user. So if I need it here, for example, to look for every, it's a search. The names are linked alphabetically. So it goes to the first word with a given capital, and here it stops. Now we can also load it because it connects the word, and the compiler also runs through the alpha link. I can, let's go to the message and load the message. It now loads everything that's needed to load this message, but nothing else. So it's a selective load, which runs through the alpha link, and it would not run through your conventional forth link. So, and what can we do else? We can have a look and load this word, hello main. And to do it, we need global names. So the namespace is global. Names up to 16 bytes, including count. But it also means no vocabulary, no current, no definition, no find, which I think is a good thing. Also, these words are redundant. On the other hand, Roland has object types. And all data words are made as object types with message, the methods, and the messages, sorry, are used in, let's go to variable or to an integer. You see here the methods are the local vocabularies which connect the message of an object type to the method. Now, what does NoApp do? To go here and have a look. Look up next, which ends in code. And this is all nice feature of the global space and alpha link. Always compile is very also does away with some complexity that I do not need. But now let's go to hello and have a look. So it runs now in a separate code space inside the same DOS memory. And go back. let's see. That's DOS keyboard, which, well, let's let it. So if I load this and show the message, it replaces the message in the existing code. Let's do it in a different, as a separate message. As a separate some may have seen this already because I showed it in Facebook. There's a video in YouTube there where we could go, and this should already be loaded. But I must change the system. So the code can be in 3 places. The first few years it was in a separate PC, 1979, 80, and now it would be here. Target code should be transferred, and so we have it here. I can't come back because you see down here, the host is blocked. So I go back here and unblock the host, it's unblocked now, and make it a task. And the task is already connected to NoForth, so I just press run. And it restarts there. And now you can, yes, now we are already at the live programming. So left is the book, which shows the program. And now we are at live programming, which is here. Hey, yeah. And I think that's about him. There's much more you can do here. And look at the code in 2 places as list code and assembler code. This is the FPC model, memory model, which I am using here. There is is on top. We could even, I want to show also the.
So I have a question.
Yeah.
So the Hello World at Zoom was your main foreground task, and live was your background task. So why aren't we seeing both of them?
Why would you see the background task? It is a task you're seeing here. The task is running here.
No, I know, but we're not seeing your can you start up the main program and then have live operating in the background? Isn't that the idea?
I'm not quite with you.
So you started it as a task rather than a program. So I would assume that your live is executing in the background.
It is already connected.
Right, but you should be able to start your main program as well and have live running in the background, right?
Okay, let's have a look at another app. Tetris as a task. I run it here as sorry, load it. It's loading now. You see here now it's there. I can run it. Oh, it runs here. It would run here if it no. So let's go to Tetris. And no. Yeah, I'm a bit too fast. So we are out here. Now Tetris should go. Here we go. You have the full code in here that is needed, just the code needed for Bemann. And go to the code space. Yeah. So the code is and only the code for the Tetris has been transferred.
But Wolf, where is now the welcome task? What is the welcome task doing?
Nothing. It's gone.
Why is
Well,
it
can't
gone?
you have multiple tasks?
No, I only one task at a time.
Well, this is a 16-bit DOS program running under some kind of Apple emulator, right?
Yes, exactly. DOS, the DOS box in Boxer version.
Okay, now I get it.
So if I know, yeah. So quit and rerun, start again. Wo bin ich jetzt? It's too complicated, folks. Too complicated. I should press run, then it's better. And what I wanted to show you is something. Let me stop it for a moment. I want to show the life change. And I prepared something for life change. Let's have a look. You break, and I wrote that. Okay. So if I send this code to load it into the target, now that worked. It's difficult to see when a cube turns, but here it works. So I exchange, it implements this command in the target, which is the separate window. Unfortunately, it doesn't know, yes, the why it's somewhere else. Any questions at the moment?
Yeah, I had a few questions on this. The first thing I saw when I was looking at this is this built using object-oriented programming? Because the first thought I had when I saw it is it reminds me a lot of Smalltalk.
No, it is not. It is built on force. You know, Smalltalk goes top down and this goes button up. It starts with the smallest part, but it's just, it starts with these words, but it's not object. The object type is just an Holon idea.
Okay, I quite like this interface. I was guessing it might contribute to reusability because you've got all of your previous work there. So I like the way you sort of approached modules and stuff. I mean, I guess my other question was, once you've loaded up your program, is there a way to export the code and the text? Because I imagine that would be really good for making reports, but if there isn't, then I can understand why.
Yes, you can, there are several things. Hold on, test. And there must be a way to, yes, you press export. Choose your module and press for export. And then it should be in my yes, here it is. No, sorry. That's another kind of welcome. A hello world. But here's it. And mod seems to be a different extension with it. It doesn't like so often admit if you edit. Here you have it. If you can use it, should also go as a, if you export text. That did not work, no. But if you export it as it is exported in a format that can be imported again. I don't know why it doesn't do this. Because there's no cursor in it does. So it is here. X. And it should be here. Yes. So voila, here you got it. And if you add to it, I would be very happy. Until now, very few people have done anything about it. Where is my... Here, could have a look at GitHub and NoForth DOS is here. So we have here the one I'm showing now. There are other forces. 11, which might be interesting for the HC11 chips, which now exist in IoT. Here's one for the JVM. Initially, I thought about moving Roland to the GUI world with Java, but Java is much too much for me. But then I learned that it all boils down to the JVM bytecode, and Roland can do this. The tic-tac-toe and hello worked until they changed the libraries. So the bytecode will not change, but the libraries that are attached. And there's, okay. What else can I tell? Oh yeah, what I would like to show you also is here we have only a couple, not much code. So it's, well, USA Roland can handle this amount of code. I would like to show you. Now let's have a look at the program which actually made Roland. It's a host 86. And that also has no more files. The source is contained in these two files, which act as a database. It's my database. Same here. These two files are the database. And you see here are a couple more modules. This module has the assembler code, the target code, and the other systems I made, I simply replaced, I replaced these two modules, and a few details were in the structure, but in principle, this is all you need to do to use the Roland system with your target. And go back. Roland also has included in this Here it has a help in the same frame, but a separate, you see here, a separate database where you can find, well, information about the way it works. And what it also shows you here about. The about shows you we have nearly 4,000 items. Which all are handled in this. No, not here. That's a help. Here, so here we have 3,000 plus items in this simple database, which I think there is quite a bit of code, and I wouldn't recommend to do something in it to make a new target. It's really hard, but anyway, it's there for you and your pleasure. What else would I like to say? You see, I'm nearly, oh no, I didn't, I forgot to tell you how many words there are. It doesn't work. So let's go and exit and enter again. The help. Where do we have it? Sorry, it takes a bit long. I need the about. I am in about. Well, there are 3,700 items in this program. Yes, here, about. About the same as false standard false has, I guess.
Can I ask a question or two?
Yes, please.
Hi, Wolf. This, yeah. Sorry, were you saying something?
Yes.
Sorry. It's hard to tell with Zoom. It cancels things out. A question. The host 86.exe, yes. Is that the full Holon program that we saw? And does it include the other window? Because one of the things I've always liked about Holon is you've got the Holon interface on the left, say, and then on the right you've got the actual executing program.
Exactly.
So I'm trying to understand which is what exactly is host 86 and why is it not the same as Holon 86?
Host 86.
Yep.
Hold on. This is fall. Oh no, that's the let's see about here we are. So this is the source for Holon 86.
Ah, right. Thank you. No, okay. There had to be a starting point somewhere, didn't there? So when you press F4, when you're highlighting run or something, or your main word, whatever it's called, in host 86, then that will create the Holon 86.
Is it on your screen here, the printer?
Yeah, yeah.
Okay. Yeah, exactly. Sorry, I interrupted you, Howard.
No, it's okay. So one of the things I've always found hard with Holon, it's like ColorForth in the sense it's an alien system. It's not like anything else. And one of the alien qualities of it is this: you split what the user sees between the Holon environment and the executing program that you are developing using Holon. And that is something I'm used to in an embedded environment where you've got your embedded hardware connected. So that's one thing that makes it hard to understand. But okay, so host 86 contains everything. When you run that, it creates Holon 86.exe. Okay, when you run Holon 86.exe, how do you invoke, or how do you create? Where does the second window come from? Which is not host 86. That's something else. Have I explained my question clearly enough? Okay, if you close or hide the host 86 one, then that I understand. That's creating Holon. Okay, that I can accept. If you go to Holon and just run your hello world program, it opens a second blue window on the right.
Oh, Howard, sorry, I'm not quite with.
It's okay.
Here you have the host. The words.
We are running short on time for the next participant. We have now three participations.
Okay.
Okay. We must talk afterwards, offline, I think.
Yes. Okay.
I have this evil idea to implement a ColorForth user interface in a Holon interface in ColorForth. That would be quite an interesting combination.
Yes.
Howard, we can do a meeting with more time for Wolf and you, and probably Ulrich can help out also. He's an expert also.
Yeah, great. Okay, thanks, Wolf.
It's interesting for all of us.
Yeah.
Pleasure, Howard.
Cheers.
Yes. So, where muss ich jetzt rausgehen? This one? No. The other one.
Now, this is the hardest part of how to stop sharing in Zoom. It's not an easy thing to do.
I can fix that.
We have you have the power. Okay, well done, Cornelius.
Okay.
Okay, next, please.
Thank you. Cornelius, Klaus, next. Do you want to?
Yeah. Please, I need the screen. How do
yes,
I get
go
it?
ahead. at the bottom, there is a button. If yours is a Windows box, down.
Share screen. Yeah, okay.
Yep. And then you pick the window or the whole desktop. The default is the whole desktop to share. Otherwise, the windows that you want to. There you go.
Okay, now I don't see the presentation anymore, but that is not so important.
Perfect.
So this talk, first I have to explain where this comes from. I made a second attempt in my life to relate force to the German academic community, and there is a working group in the German equivalent of the ACM that deals with compilers and computer architectures, as far as I remember. And so I thought this is the proper group to talk about Forth. And when I was there for the first time, it became clear to me that there is worldwide a small, but it seems growing group of people who are no longer happy with the way that traditional compilers work. Namely, the compilers that are based on a grammar and try to enforce the grammar on the source text, and if the source text fails to abide by the grammar, then the compilation process stops. And so several people had the idea that perhaps this grammar-based method could be replaced by a method which they call the lexicon-based approach. And if you look at the lexicon-based approach, this pretty much looks like the Forth dictionary, actually. And also at the first meeting, it became clear to me that they do not have, by and large, they do not have any idea what Forth is and how it works. And this is why I prepared this paper, which I called Poor Man's Compilers. Please note that compilers is plural because Forth doesn't have one compiler. It has several compilers, which do only small things, but these small compilers interact with each other. So the topics, how Forth, I can leave out most of this, and so I just go ahead. You know this guy, and how this was all developed. The Forth system, and Forth is based on a simple virtual machine. It is Forth. Forth is the assembler of this machine. And I made extension to the existing diagrams that we know for a long time, because I added the dictionary, which in computerese is called the symbol table. And I also added character IO that communicates with the top of stack, because this is essential to Forth. I mean, you couldn't have a Forth system without the dictionary and character IO. Unless, I mean, you use the Forth language to do a closed embedded system, cross-compilation, in which case, but then still, the dictionary is on the host computer that runs the cross-compiler and spits out pure object code of the target machine. And the dictionary, and this is what Forth calls its symbol table. So it became, talking to these people, it became clear to me that Forth has been a development by engineers who were solving actual problems in the field. And they didn't so much talk about other computer science people. The end result of which is that the computer science people use different terms to describe the things they are doing than the Forth community who invented their own words. And that makes communication, to say it mildly, a little difficult, because quite often I didn't understand that they couldn't understand the terms I was using, and then I didn't know which terms they are using to talk about the same things. And I think this is something the Forth community as a whole has to work on, because if we are not able to use the proper words in the academic community, we will never be able to communicate with them. So I explain what the dictionary is. Basically, this is what they call the lexicon. And since we have several vocabularies, that is not clear to me whether in their lexicon approach they allow for several dictionaries, but I mean, we have them, and therefore we can have identical names with completely different semantics in different vocabularies. And parsing in Forth. Now, this is very, very different from how existing compilers do parsing. Because we only look for white space to identify a word. I mean, pretty much like we read books. We also look for white space. And this means that the lexical scanner, as this beast that extracts tokens out of the source code, is extremely simple and not really worth talking much about it. A result of only looking for white space as a separator is that any ASCII character except white space can be part of a name or an identifier, how this is called in the computer science field, which is a very big advantage if you have this capability of using any special characters, like, for instance, a quote. If there is a quote in the name, we all expect this word to operate on text strings. So this is a semantic hint of what the word is going to do. And I adopted the standard that my constants always start with a hash sign at the first position. So by just looking at the name, I know, aha, this is a constant. Like other words, if there is a dot in the word, we all know this has to do with displaying something on the screen or on the printer. And basically, that we can use these meaningful names and are not limited to alphanumeric characters plus the underlined character. And boy, have I been angry in the past when I used other programming languages and I couldn't use the full ASCII character set to make up names, and I had to use different things. It all starts already with a minus sign, like Forth uses minus as a separator of words that consist of more than one. it's difficult for me to explain this in English because I don't know the grammatical names of what we are doing there. But we use a dash to say save buffers. The rest of the world cannot do that because minus in their systems would be a valid separator that separates the thing that is before the minus from the thing that comes after the minus, and these would be two different tokens in the system. Of course, then I asked myself, why is this so? And I came up with two potential answers. Perhaps there is a third one. And these are as follows. The first idea that came to my mind was, well, when the first compiler, namely Fortran, was written, it was the time of punched cards, and every column in a punched cards costs money and steals you a position from your maximum 80 character long card punch lines, so to speak. So that may have been a motivating force. What is even, I think, more convincing is the second reason I found. Well, Fortran is a short name for formula translation, and the main reason for Fortran was to make it easy for scientists to write down mathematical functions. And mathematicians for a long time have already always left out spaces when they used a plus sign or parentheses. I mean, they don't have to separate parentheses or the plus sign with spaces. So, and if you look at math textbooks, that becomes obvious pretty easily. And therefore, I believe that the Fortran compilers saw this as a challenge to write their lexical scanner in such a way that you can write down formulas like you see them in the textbook. Which is fine, which is an extra challenge, which is not really necessary, because it doesn't add any functionality, but it adds a lot of complexity to the lexical scanner. And thanks to this policy in writing compilers, the regular expressions were invented long ago, and we don't need this in Forth at all because looking for white space is trivial. It would have been nice if this special, let's say it's character software layout would be confined to Fortran, but it is not. The second compiler that was realized was COBOL, and it seems that the COBOL compiler writers looked at Fortran and they found, oh, they have this highly complex lexical scanner, and perhaps this is really necessary, and we do it the same. And this kind of like was inherited by almost all the languages we see that like since those times, which go through this extra complexity, which, well, just makes the compiler more complex. And actually it kind of creates a priesthood of compiler writers who are able to deal with this kind of complexity. We don't need all of that in Forth. I'm still trying to find more programming languages that also only look for white space, and the only one I have found, if this is correct, is, as far as I know, Lisp does the same thing. And I would be very happy if I could hear more examples today from the group, which other programming languages also only look for white space. Any ideas? No. So I leave out the rest of this because this is directed towards people who don't know Forth. Compilation in Forth, we know how that works. I don't have to talk about it. The immediate bit, you also know what this is, but this is a point I wanted to make why Forth has several compilers, because every immediate word is a small compiler. And so this, as an example, the conditional, we have the if, which is immediate, and we have the end if, which is immediate, that does certain things, and kind of the end if picks up the address that is left by the if and fills in the real target address. This is known to every Forth or Forth programmer by heart. This is a proper place to talk about the check digits. Now, the if not only leaves an address, it also leaves a check digit which says, well, I was an if. And the end if just looks whether it finds the I was an if, or whether it also finds I was an else, in which case the end if, does it have to do something else? No, I don't think it has to do something else. The else takes care of it. Anyways, so yeah, you know all of the rest. So in Forth, there is hardly any predefined syntax and no global compiler that checks the grammar rules of the source code. Instead, there are individual small compilers that interact synergistically to generate syntax. And additional compilers can be defined as part of an application. And this is the fruit we can pick because there is no global compiler or grammatical check. And so other people who want to extend their compiler for an application, I mean, they have to go through the tremendous pain of modifying the grammatic-based compiler so that it can crank out additional constructs. And you cannot do this inline while you are defining your source code. This is something only the Lisp and the Forth people can do. And so we have a system that has a dynamically extensible syntax. And this is something we can be really proud of. And thank you, Chuck Moore, to giving us this capability, which is only possible because the lexical scanner works the way it works. I made an example for those guys of how far you can go in Forth with I call the syntactic sugar. I had a nice example, was discussed in Vierte Dimension, which is the 4 times a year paper of the Forstgesellschaft in Germany. And at some point, somebody wanted to convert ASCII text into Morse code tones. And so as one of the things, you have to define a table of the Morse codes. And this is potentially error prone if you try to do this by hand. And so with this kind of syntax, it is easy to check whether you got it right or not. I mean, you just have to follow the dots and dashes, the dits and das written down, and that relates to A. And actually, to do the compiler for this, Well, it's 2 screens actually. I'm not going to talk about it. So this is the beginning. And to make things, I did it in a way which is tricky. The dot leaves a 1 on the stack, and the dash leaves a 2 on the stack. And before I start, before I start with the dots and dashes, the Morse table already puts a 0 on the stack. So it is very easy for this vertical bar word, which is the actual compiler for one Morse code, to pick up the 2s and 1s. It has to do this until it finds a 0, and then it knows, okay, I've picked up all the tones. So that is easy. All these definitions are collected in its own vocabulary. And then, well, yes, if you are interested, I have sent these transparencies to Peter already, and they should show up on GitHub shortly. That's it. Questions, comments, and whatnot.
I loved your talk.
And so do I.
Well, yeah, I want to add something to my talk. I mean, it took me like 35 years or so of force programming until I finally understood what I was doing there and what was different.
You know, when you look at the big picture of programming, really high level, at the evolution of C, then C++, then Java, and then what they're Rust and Python. They're like building all these huge languages, and they're trying to get to where Forth has been since 1963. You know, in a very small space. But I find it fascinating. And you ran across these guys that are basically, talking about, compilers and parsers and stuff, and you're kind of going, look at this, look at Forth, right?
Yeah, I mean, I just wanted to let you know that you can do it completely different and more easily. And actually, I found one who really started to develop an interest in Forth. Well, basically, what this group of people who are no longer content with the grammar-based systems, I read a paper about it, and they had a couple of requirements that such a new lexicon-based language should have, and I could easily write down how Forth does it. And so basically we have the situation, they are coming to the point where they want Forth, but they don't know that it exists for 40 years already.
I love it. I totally love it. Keep us posted on how that goes.
Really.
One
Very
thing that
nice.
is very common is that engineers love complicated things. And when you look how standard compilers are written, it's extremely complex. And Moore, which they didn't have to believe in, said, no, look how simple it can be. And that's where we are. They love complexity. We love simplicity.
Oh, yes, I have something to add. There is also, in this move of people who want to turn away from the grammar-based systems and going to the lexicon-based systems, I didn't find the paper, but they already proved that both the grammar-based approach and the lexicon-based approach are capable of covering the same width of languages, namely context-free grammars. And so the grammar-based approach even doesn't buy more capabilities, so to speak.
Klaus, we have two questions. Hello.
We have two questions, one from Greg and the other from John Helmers.
Yeah, I just had a couple comments. One's kind of a detail. I liked your Morse code example, and I like when the code resembles the domain, which it certainly does in that case. But just curious if you considered making the dot and the dash compile words so that they would basically compile either the 1 or the 2 directly in there, and then you could eliminate the OR bar and the entire loop on the stack there. Just curious if there was a reason why you did it the way you did.
Naja, I didn't do the initial work. I kind of inherited the syntax, and I just changed, and I considered the implementation as being too complicated at the time, and I just replaced it with having dot push a 1 on the stack and the dash pushing a 2 on the stack, and then doing the processing of the code of the code that is stored in the Morse code table consists of a sequence of zeros and ones, depending on whether this is a dit or a dot or a da, and the number of tones.
So I think,
and so this
I think you
is
would still need the terminating bar to indicate the end.
Yeah, it's not the terminating.
Like.
Yeah, it's the terminating bar that also tells you what the character is. It looks one step ahead, doing a char in order to find the index for the Morse code table.
Right. The other comment I wanted to make is about things being language elements being reinvented. You really see that today with the resurgence of so-called functional programming. You see everything that Lisp was ever always about being re-implemented today in modern functional languages, and it's just kind of interesting. And in a sort of a related topic, I work in the industrial automation industry, and our development software, our application software tools that we provide our customers, it's the same thing. I mean, we're starting to like discover object-oriented programming in the, in the industrial space, and you'd be surprised that what we seem to get patents on are things that have been around forever. And it's almost like there's nothing new under the sun. When you apply it to a different domain, it's considered new. Anyway, just some observations.
There was another question.
On Helmers from John. Are you there?
Peter, your volume is very low.
Yeah, Peter, your volume is very low. That's true.
I would
see.
like
John Helmers.
No, but I take the opportunity to make another comment. So I studied computer science until I dropped out because I found punching cards not very exciting. But I listened to a lecture on compiler building, and I had that made a deep impression on me, and I was in awe towards the priesthood of compiler writers. Now, finally, after I learned Forth and I understood how to do this, I mean, this all just blew away because it is so simple and understandable.
I once looked at the C compiler, and it was kind of interesting because the C compiler creates this little interim language that looks a lot like Forth doing a bunch of stack stuff, and then it turns into the object code, I guess, the assembler. So it's interesting how the pieces of way Forth works is in almost every language.
If you show Forth to a computer science person, that's exactly their comment. It looks like the back end of a compiler, which it does. It's just you're that much closer to the machine.
And partially it does. If you take a look under every Linux or X-based system, you either have Lex and Yak or FLEX and Bison. And they do the heavy lifting that they take source code apart, run through it, and present to the code that's calling it a somewhat more palatable presentation of what you're looking at. But fair warning, neither one, dealing with them, neither one is for the faint of heart, because there is a boatload of pitfalls. In Forth, that's simple. Find space and figure out what you have and do it. Repeat until done. If you look at more complex languages, maybe not so much Lisp, but most others, you will encounter in the compiler or interpretation thereof a lexicographical analyzer and a parser, for which you get to write plugins. Enjoy. More questions?
I always felt, it's the computer science people wanted to keep it. They were like the priests of computer science, and they want to keep it where we have to go through them. We have to go through their languages that they designed, and they have to be complicated.
Now, let's be fair. Some languages, there are enough use cases where domain-specific languages have a purpose, and all these tools come in handy dealing with that. Forth can do certain things in spades, and others not so much. Now we expand that, replace Forth with anything you feel like, and I can find you a good use case, and somewhere it's going to be an absolute disaster. But Forth has its strengths, and they're not being recognized, and that's why we're here.
Well, Forth is so malleable, and to me, Forth is a meta language. It's not just a language; it's a language to create languages, which is what thinking Forth is all about. And I think I would challenge you on Forth not being able to be applied in certain areas.
Oh, easily.
Give me one.
But that's aha. We have a little bit of a time ticker, and we have at least 3 talks left. Do we? Where's my overview? Found my overview. Didn't find my overview. Pop-ups from hell in here. I hate that.
No priority interrupts. Keep going.
That's Facebook to you. That's Facebook to you. They pop up these dumb message chats in your face, overlaying the good stuff. So that's, by the way, how you're not supposed to do web page design. But hey, what do I know? I'm an old fart. Okay, next. NoForth news.
Okay.
Willem Ouwerkerk still here with us?
Yes, I'm still there.
Okay, cool.
I was just adding a link to the NoForth zip in the chat.
Okay.
Just fiddling with it. I think I succeeded now. So it's there, so I can start.
Go for it, all yours.
Okay. Now try to share. Yes, Zoom is back. And now, am I still there?
We still see the overview. You're not sharing yet.
Yes, but I have troubles again with Zoom. It disappeared when I wanted to do something. But I think I'm back now, and now I'm trying to find the share button.
Bottom of the screen, right in the center, green.
Yes, nice that you say that, but my screen is all white.
Ouch.
Ouch, yes. Whiteboards, home. Oh, yes, I'm back. I was just lost in some part of Zoom. Now I can share.
And there we go. We can see your desktop.
Okay. Then it's there, so this can go away. Now about NoForth. We just are finishing NoForth. Last time I talked a little about it, and I want to go through it one more time. You see here a terminal screen with NoForth booted and some tools loaded. Yes, the assembler, disassembler, and some primitive PO base. And NoForth, that stands for thumb, is a little bit different than other NoForths. Other NoForths all run in flash or FRAM memory. So they need special care for the dictionary and compiling. So because NoForth runs in RAM, we can use a value just like standard does, with an initialization value. So that's nice. It's a bit more standard that way, and we have grow because we have a lot of memory, and so you can modify your dictionary size. If you finish an application, for example, you can grow dictionary so there's only it needs only the space that the program uses. That's one of the examples. And if you need more space, you can ask some more dictionary or some more RAM to work in. So that's about grow. Then we added a feature to save more than one dictionary. I must say image, of course. The freeze is the standard save in NoForth, and it saves for the flash versions just the init values, and it saves them in flash, in a special part of flash. But this system runs completely in RAM and boots from flash memory, just like the Raspberry Pi Pico boards do that. So we have two freezes to save two different systems. So you can, for example, work in a minimal system, and when you like to experiment with assembler, you ask the system to load the other version, and you can experiment with assembler. And then add those words to the minimal system. So you can have a large complex system that does a lot for you, and a minimal system to build your application on. That's one of the ideas about the two images. Then, because the Pico chip, the RP2040, has two processor cores in it. It looks nice to run on such a system, two Forth systems. So we tried that, and it works quite nice, and we call that NoForth Duo. Because when you boot the first systems, it takes a next step, booting a second system, completely separate from the first one. And that's nice. So we have a real multitasking on a really simple board. And then there is the PO assembler and disassembler. I already did talk about that. and it's not in the basic system. It all are loadable files. So you can, if you want to experiment with it a lot, you can load them and freeze them. So you can work on it time and time again. Then there's another small file. This is called core1.f, and that is a file to add features to boot the second core. And it's also because it's also possible when you run a single Forth system. And for example, you build a really heavy interrupt driver. Then you can say, well, this interrupt driver must be executed by the second core. So your basic core keeps clean and fast. And that's a very nice thing of this, a nice and cheap board. I'm still puzzled about the price and the possibilities you get with it. The NoForth T comes in 4 variants. The T version without vocabulary is a TV with, and then the same for Duo and TV Duo. So if you get the zip file, you get 4 binaries in it. So you can choose in which one you will work. Some people get really worried about vocabularies. I really have some quite experienced programmers who sometimes call me and send me a mail because they have loaded another version of NoForth on it, and a lot of words are not there anymore. Sorry, but multiple vocabularies are not for everyone. Well, not for every beginner. It's a little get used to. I really can't understand work without vocabularies, except for very small systems. And now some details. Freeze saves the startup image. Freeze 2 saves the alternative image, and the same for cold and cold 2. Cold boots the startup image, or reboots the startup image, and cold 2 boots the alternative image. Then we have a system clock that can be adjusted between 12 and 250 megahertz. 250 megahertz is overclocking, and I show you later that it really works nice on this chip. It's nothing to be scared about. Then I like to mention all the authors: Jeroen Hoekstra, Willem Ouwerkerk, Albert Nijhoff, which I work with for a lot of years already. I also try to ask him to give some talk here because he's a very original programmer, and I like his views on Forth. And then we have a meta compiler that will be available soon, also in a separate zip, and that runs on Win32Forth. I think it will not be too difficult to run it on G4 too, because the other versions of NoForth, for example, the MSP 430 also runs on G4 with a very minor fiddling. And then NoForth comes with a lot of extra files like the assembler, disassembler, comma code. A comma code is a special case. I just mentioned that you run a large system on in one image and a small system in the other. When you're running the large image, you can create and test assembler words there. And if you want to keep the other system small, you can the words you create in assembly, you can build comma code from that. And comma code is just a separate compiler that analyzes your word and gives a small ASCII version of it with only hex codes that will run on the other system without using the assembler. And that's very nice when you build a large program with some coded words in it. Okay, then we go to the NoForth image. This is the way the NoForth image is stored on the flash card. Like all other, they call it UF2 files. They have a secondary boot that loads the code behind it. That is, without it, it won't work. The Raspberry Pi bootloader checks for the secondary boot, and if it's in the right format, it will execute it and load any program you add behind it. So behind the secondary boot, we have the first NoForth system, you could say the basic system, and you have the Duo version. You can add a second image behind it. They must be included in a binary that fits behind each other, but I try to store it as different images, but it won't, the bootloader won't work with that. So I store the port systems just like a counted string with the length in front of it. So it's easy to boot both systems. And there are also some things to do. The first stop, I like to build the Duo version, and that's ready. And also I like to do some overclocking. In geval experiment with overclocking, and that's already in it. The next time I hope we will have interrupt examples and calling some more ROM functions. And especially it's for all browsing documentation and decompiling the code that is already in ROM. I loaded already my NoForth, my small NoForth file system. It runs a little bit, but not very nice. And that's because I have to find the correct QSPI routines. That doesn't do the basic routines that they mention in the datasheet, do also a flush of the how do you call it? Flush of the cache memory. And flush of the cache memory takes about 300 milliseconds. And if you're loading a file 300 milliseconds, you lose a lot of data. So that's something to work on. And I got some questions to use a serial port using the built-in USB. It doesn't have priority for me, but when it comes to it, maybe when there's time, if somebody has browsed the ROM system also for that, because it's already in the ROM system, then I will really like to add it, but it's not a hobby for me to add it. Here is the NoForth configuration example. It's just an ASCII file, and this is the real code. It's just 5 cells. The first cell sets the clock frequency, and these are valid frequencies for it. The second cell chooses the muart. In this first version, only muart null is used, because I really like to run it for some time before I add the extra complexity. The baud rate, you can just add the number you want to use, and it translates it to the correct numbers for the hardware. The basic speed is this for 460K800, and I tested it until 921,600, but it all works nice, and with really small delays at the end, only 1 millisecond is enough, so it compiles quite rapidly. Then the next configuration is the I/O pin that is used for the word S-question, and S-question is used in NoForth as a security item. When you boot the system, you can add code to the app vector, and when you make a mistake to it, or you want to add some extra complexity to your program, or make it, of course, much more simple, like just was shown, because you get a better idea for the implementation, and then you can stop the app vector by pressing the correct key that disables the app vector. And we really like that feature in NoForth. And of course, when you build a real application, you can add a number that doesn't do anything. So it's you can really seal it, but when you're working, it's really nice that you can skip the app vector. And finally, there's an extra cell, and in this cell there can only be 0, 1, or 2. If there's 0, it's a single NoForth system. If there's 1 or 2, it's a dual system. And if there's 1, it only loads the second image, but does not start it. And if there's a 2, it loads and starts the image. And you can quite simple test it by just download this piece of code, the final line CFG config just it tests the new configuration, and if your system keeps on working, it's okay. And if it doesn't work, then you try another. And if it's final, you can use the words freeze or freeze to save it in one of the 2 images. Now, about how does NoForth boots? It has a very small, a very limited assembly code for the boot up. This is the only part that is really in low level, because there are of course several other low level words, but they're all factored out. The only thing they do is I give it some colors. The blue one is the address of the bottom of the return stack, the bottom of the data stack. The origin is the start of the code, but also there's a small macro that adds the does functionality, the low level part of does. And finally, Amsterdam contains a link of the address of the high-level code that boots NoForth further. And this line here loads this data. So this is a small literal pool example. Most assemblers use this outside of the code word, but that brings a lot of complexity to the assembler, and I like to keep it simple. So if you're working in Forth, you can a normal Forth, you don't have to use this pool word. This pool word is meant specially for words that are executed as subroutine or as interrupt routine, or like this. A boot up program. You can see it in the first line that it fills the warm start spectrum. And that means that NoForth isn't running there, so the registers are not filled yet. So you need to add a marker for the code so that it knows where the constants are. Now, and this is what it does. It just says, copies the program counter to the W register, and you can use the word LDM to read all these constants in one go. So you have all the data ready, and then you can go on, initialize, read the return stack pointer, store it in the next, read the stack pointer, and store it directly. That can be in one go. And that is because the return stack pointer is a high register and there are only few commands that work on high registers, and one of them is move. So that's why it's there. And finally, we initialize IP so it can run high-level code, and when we execute next, the port system runs. That's the complete boot of NoForth. And when it boots, it jumps to like I said, to a high-level part. That high-level part, it's called config, and it configures the chip completely in separate parts, like doing the clocks, reset different hardware parts, and so on and on. But it also boots the second system if it's there, and that is this part of the code. This checks if the multi-core is used. If multi-core is used, then the hey fetch delivers a 1 or a 2 and not a 0. If it's a 0, then it's a single system and it's ready. And if it's a 1 or a 2, it loads the other system. And if it's a 2, it also boots it, and that's the line here. And memtop is the end of the first system, and because the second system is right behind it, it means that the second cell behind memory top, there's the reset factor of the second system, and we read that and call the boot program that is here. This is this small word is all you need to have to boot assembly code on the second system. And what it does is this: it sends a special sequence of numbers to the other system, and it does that using the inter-core FIFO, and the word to command what it fills that. It just stores the data on the stack in the FIFO. And so it sends a 0, 0, a 1, the vector table, the stack pointer, and an address for the program counter. And it's all in closed loops, because when we send the first command over here, you get a response from the returning FIFO, and it sends back the same command. And in that way, you know that the second core listens to you and still keeps on working. So every step we take, we need to get a response, and if it doesn't respond, we just empty the FIFO completely and start over again. And most of the time it goes all right in one time, but this is the preferred method to start the second core. So with 001 is a special key to start the second core. Then we send the interrupt table, and then we send a temporary stack pointer, and finally we send the PC address. And you can use this for any code routine you want to have executed, but also, as you can see here, for a complete Forth system. It just boots it and it goes on running like it's all in itself. It's completely free. It's almost completely independent of the first system. The only thing that they share are the interrupt table. So when you use interrupt factors, you need to take care. And I think that's about it. And I want to show you how it works. Here are the two systems. The top system is the basic system that boots. And when we execute the word call there, you can see it starts up again. and it starts with the second core too. And we made some visible strings a little bit different. It shows TV2 so that you know that it's a second core. And it also has a slightly different prompt. The first one has a pattern behind it, and this one has a greater sign behind it. So you can also use them independently because they are completely and of course compile code in both systems. And yeah, that's it. That's where NoForth stands now, and we are just finishing documentation before we add it to the website. We are quite far with the assembly documentation. Not completely finished, but almost finished. Any questions yet?
I pulled up the data sheet on that, and I thought I heard Peter talk about that the cores have to share the memory. In the data sheet, it sounds like they have a memory manager that allows at least 4 cores to access memory, but then there's another sentence in there about it almost sounds like they can't access it in one clock cycle. Can you address that? Can each processor access memory in one clock cycle?
I think so, yes. I didn't find anything about it that they keep each other behind. No, I think they're completely independent and run completely full speed. Because I think it's nice to do some tests on it.
Yeah, it'd be really interesting to do some sort of like memory scanner test.
Yes.
And have both cores doing it. And maybe at different pages, because I think it's set up to it makes each page a quarter, and then every quarter page is for each processor, but every processor can access all of them. Maybe is that kind of what I'm reading?
And I don't know exactly. I just have to check that. With what I already tried yet, it looks they're completely independent. So, and also with what I read in the datasheet, I didn't find any mention that they could be in each other's ways. But it's a quite big datasheet, so it's easy to miss something like that. So I think I should build a small test to try to time some simple function that just for example a small counter, and there's a really good tick counter in it, so it should be easy to find out if there's any problem.
Yeah, that'd be very interesting. It's an amazingly powerful chip for its cost. One of the things I've been looking into this last month is like a DDR memory. When you access it, I gotta find my plug-in here. Let's see. It can, if you get a page hit, you know, it might on DDR, I think it's a DDR3 data sheet I was looking at, so it may not be the DDR4. But anyway, it takes like 25 nanoseconds to access data in a 4K cell, the page buffer on a DDR chip. But if you have to swap pages, it's 125 nanoseconds. And like I say, this may not be DDR4, it might be 3, but the concept is still the same. This processor, the 2040, uses internal SRAM just like our Core 1 does, and which can have like a 3 nanosecond access time. So, you know, even if you were time slicing the memory, it still would be way faster than a PC. Another very interesting test that maybe you could do is write the same code on a PC. and I'll bet you dollars of donuts it's 10 to 20 times faster on your $2 part than it is in your laptop.
Yes, yes, I think so, yeah. But I really like this chip because it has such a lot of nice features. I also very much like the PO. It gives a lot of extra functionality. You really have about, I think, about 10 small processor cores together with the 2 larger ones. And it gives, it's a sporter, with our systems are quite small, so we can do a lot with it on such a chip. Any other questions? Sorry, Don.
No, go ahead.
No more other questions? Then I think it's time for, I had one thing to say, that is that in the chat box, there's a link to the binary, to the image, and also all finished documentation. So if you like to play with it, you can do it. Quite simple. Okay, that was it. Time for the next one.
Amazing.
Cool. Thank you so much. Good show.
And now I have to stop sharing. So time for someone else. I think it's you, Uli.
Thank you very much. Okay, yeah.
Thank you, Peter.
So if it's me, then that's fine. I will keep things short, but I have several interesting things for you. I believe that are worth waiting. I share my desktop. And let's see, so, well, this goes away and that's fine. So the first thing is that Wolfgang Strauss is working on an international version of Vierte Dimension. So most of the parts is of Vierte Dimension is German, and we have, for many years we have one international, most of the time English article for our international readers. And Wolfgang said, well, it's great. I want to give the community a service, and I will translate all of the magazine. And we agreed that he will do this for a year, for 4 issues. The first issue is available. I will post a link to that in Facebook so that people will know about that. And of course, he's looking for volunteers. Especially, we need native speakers that will go through our translation and give a thumbs up that everything is fine. And I will forward you to Wolfgang's email if you are interested, or I will add this in the announcement, because he's the one who drives this. I'm just a messenger here. So that's probably something very nice. We recognize that fourth dimension or Vierte Dimension is actually the last fourth publication in print. So we still have a printed version of the German issue, but we decided to have only a PDF version of the international issue. Yeah, so that's the first thing. The second thing, I had been playing around with Resemble.ai. That is a company that captures your voice, and you write about a paragraph of a text, and they capture your voice and they analyze it. And after that, you can just write text and it will speak in your voice.
So, and to see if this works, we have to find out if this is all fine. And I wonder whether or not if I submitted or shared my screen. I didn't enable the sound, but now I have. And so let's see what this is the prompt. I would like to talk about digital signing for source code and so on. It's not a recording. It's generated from a completely different sample of my voice, and let's hear what it sounds like.
I would like to talk about digitally signing forth source code programs. You can sign a program with your GPG key, and others can verify that you are indeed the author of that source code. That's how this works.
Okay, I would like to talk about digital signing for source code programs. And then there's that, and so on. Yeah, you have to judge whether or not this is similar to my voice or not. And I will later listen to the YouTube recording and we will find out. So yeah, this was just from a single paragraph of me reading and not from further text. They say, well, typically you need about 3 recordings in different situations to actually do things fine. Anyway, so that's just a flashlight of things that emerge. Let's have a look at a very simple forth program, and I will now talk about signing this program in a way that it will be forged maybe and to prove authentication and authorship of that program. So that's a very simple program, and I can go ahead and just run this program in GForce, hello-pure.fs, and this is what it does. It loads it into GForce and runs it, and that's it. And now if someone changes it, then it obviously is no longer my program. And well, for a simple program that doesn't matter, but for a larger program that might be actually an issue to prove the ownership of something that you provided and you developed. And so the idea is you can go ahead and sign this. And let's see, I say sign in this way. Take the hello-pure.fs program, the one that we see, and create a hello-fs program that actually has the signature in it. So it says, well, actually we see hello.f already exists from a previous experiment and proving and try out that all works. And so this is what I did. And so let's have a look at hello.fs. Yeah, hello.fs looks like this. Here's my program, and it has this PGP signature, which is an asymmetric encryption protocol that allows to sign documents, and later on everyone can check whether this is original or not. Yeah, and so if I'm going and do a verify, yeah, then I can take this program with the signature and try it out, and it says, well, everything is fine. Yeah, it's my good signature. I signed it. Well, this is all set up taking the defaults from my laptop setup. And but now, can I run this? I mean, / begin PGP signed. That's obviously NoForth source code, or is it? And if we look at the first line, signing it also include gpg.fs. And this is actually some magic, very similar to the things that I do with self-replicating programs or Markdown setup. So I can run also hello.fs in the same way. And it goes ahead and now let's have a look at gpg.fs. It goes ahead and knows and defines these PGP things to be just false words that it ignores most of the time. And then there's this other thing that you need to do when you want to skip this here. You have to skip arbitrary text in between begin and end PGP. Yeah, and this is what this actually does. Well, signature is the one that is that's interesting. So signature is a false word that actually skips all this stuff and then continues. So that's quite nice. Or maybe we could just say signature would skip till the end of the file. That would also be possible. But here, as it is, it just skips until it sees end. Yeah, and that's it. So that's the secret why you can run hello.fs, although it is digitally signed. And now let's do something. Yeah, signed and modified. So someone changes something in my source code. And now, of course, you can run it. But if you verify it, then it will say, no, 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 that's not from Uli anymore. It has been modified. And so I can prove ownership of the original version. And I can find out that the program has been forged and modified by someone else. I don't know who. And it's not the original one anymore. And so I think that's quite handy. And the nice thing is, again, Forth allows us to process tokens that are in the input stream by just defining words. And that I think that is very helpful and indeed very nice. So skipping here, I could also say, well, not signed. And let's see, we go here back again. And then let's see if I do a verify. Yeah, then it's again good. The code in between is fine. And now if I run it, then it will run signed code in between, and it should, well, it doesn't. It should in principle. Well, that might be something that we want to go after and run and enhance this. It should stay with the end and not, and then the idea is it should execute the code that has not been signed nevertheless. Yeah, so you can have paragraphs where you have signed code in it, and that's it. Yeah, so that's what I wanted to talk about, short talk, and maybe an interesting idea for you and some exciting news. Thank you very much for listening, and yeah, and stop sharing, and I'm open for questions.
That was good stuff.
Mm-hmm. So
yeah, very interesting.
You were able to hear the generated audio?
Yeah, and it doesn't sound quite like you.
It doesn't?
No.
Yeah, great. Okay.
So it's close. It's close, but not close enough.
Not
you need
close
some more
enough.
training.
Yeah, obviously.
It needs more training, yeah. I will try out. I will try out.
It puts the artificial into intelligence.
Yeah.
By the way,
virtual
did you
intelligence.
Yeah, no kidding. By the way, did you just please tell me that was not your real GPG private key?
What do you mean?
Because we now have on the video your real private key.
No, it's a signature.
Mm-hmm. Yeah, no, it also had the, if you look, crap, that scrolled out. You need to go up a little bit. The very beginning. Here, halt, go down a little bit. Halt, that's it. Using D5 blah, blah, blah is default secret key.
Yeah, but that's only the fingerprint.
Okay. Oh, okay. Gotcha. Gotcha. Gotcha.
Yeah.
I thought that was the real thing. Okay,
no,
never mind then.
The thing is much longer.
Okay, good.
It creates a new key for every time you use it.
No, it's a because it's asymmetric. You can look up my public key in the key servers. So you are able to also verify that something is from me. Yeah, I have my private key in my local store, and I won't show it here. And this is used for actually signing and uses the default. This creates this one. And if you know the public key, then also you are able to find out that I'm the author, that I signed that document.
Uli, I didn't understand completely how you added the signature. So do you take the raw forth file and throw it into GPG to add a signature?
Yeah. So let's see.
So how does the sign work?
So this is sign, and it overrides the file. And now if we verify it, it will probably also say that it's signed on a different date. Yeah, signed May 20, 2012. And you see it's now 8 minutes later. So the signature has also a timestamp in it. And let's see what sign actually does. It more or less, it does this GPG line, does a clear sign so that it doesn't put it into binary. And then it prepends the include file, or the include line at the top. Yeah, so from this, we go to this by mainly piping hello pure.fs into GPG that does the signature for me, and then prepending the include gpg.fs. And luckily enough, if you verify a signature, it will just scan for / begin PGP signed message and skip everything that is in front, and then find the signature, find the part that is signed, and then finds the signature and verifies that everything is in place. Right.
Nice and
Very
beautifully
nice.
simple. Yep, and simple.
Yep.
Okay. Thank you very much for listening. And I don't know what the schedule is. Who's next speaker?
Next one up is too many windows on screen error. Christian Hinse, Quadrature encoder on Bluepill, employed in CNC.
So ready to do it.
Have at it.
Be quick and mostly words, human words and pictures. Okay. So do you have the screen now? No, I'm probably.
Yes, screen is up.
Okay.
It's all right. Yes.
All good.
Okay, so the goal for me today is just to show you a hardware timer in encoder mode on a Bluepill. And the reason why I did this, it all started with my friend here that had this amazing setup to modify a lathe, this one. So what I'm trying to get to work here is these optical rotary encoders. These two are really going on the plate that moves parallel to the spindle axis. And this one here goes on the spindle itself. His first attempt was trying to do this on a single Bluepill with an Arduino code that was intended for a nano, and it didn't work. So he said, I'm gonna work on this interface, which is the user interface on the NextGen. And he asked me to see if I could find a better solution that does not generate 3,000 interrupts. So I said, okay, I'll take a look at it. And to experiment, I didn't want to do it in Arduino. I decided I'd do it with Forth. So here's my setup. I tried it first with an Arduino feeding the Bluepill with, well, you don't see it much here, with a rotary encoder. I didn't like this approach, so I pulled out my PyPico that is also running Mecrisp, and I generated the equivalent of a quadrature signal that would imitate this rotary encoder without the annoying switch bounce. So the software I use is the Bluepill diagnostic. You get it from this site, and it's a bit interesting. See this site here. It's worth going through. It has some nice features that make testing with Mecrisp more easier, let's say. Okay. So no, I'll just bring this down and we'll keep on going. The rotary encoder mode example also comes from that same site. It was intended for use on a STM32F051. So to make it usable on the Bluepill, I had to read the reference manual for the 051, as well as the reference manual for the STM, the Bluepill, which is also called STM32F103C86, I think. If you want to get those reference manuals, you could get them from here. And to be honest, this is not the most interesting reading. Here is what it looks like for, and it's got 136 pages for the Bluepill, and almost the same thing for the other one. Okay, the essential part that summarizes everything, a nice picture of a Bluepill, but it doesn't make much sense unless you read the reference manual. But we'll be using 4, 5, 8, and 9. 4, 5 will be the input, while the signals coming from the rotary encoder, and 8 and 9, I use them in a test to prove that things were working, their output bits. This whole thing is just a matter of setting bits in a register. So that's what I'm showing now is just what it looks like in the manual. This register is the configuration register for a timer. X stands for, I think, 2 to 5 in the case of the Bluepill. And there's a whole bunch of those that reside at the base memory in the memory, and a whole bunch of fields where you set bits. You do this with the command called, if I remember, bit BIC and BIS, set and clear. So I'm not going to go through the details of all the fields and what they do. But the process for me was basically analyzing the 51 code, analyzing the manuals for the 2 MCUs, and creating words to configure the various registers, something like 6 or 7 of them. Prove that the Bluepill GPIO registers are properly configured. I had a small program that did that. Maybe I should show you. Let me see if I have the word that does that somewhere. Let me just guess and see if I can show you. So that's my development environment. I'm basically using Xshell 7 that gives me a terminal here and gives me an editor, a limited editor there. Okay, I also use for really editing my code, Notepad++. And this is roughly the code that I got from the Mecrisp site, unofficial site. Okay, it's way too complex and it would have to be simplified, but it is mostly constants that define where the register are in memory, and a bunch of words that define fields, and then words that modify fields in those registers. And we finally come to something that initializes the registers to do something with the GPIO, and then initializes the timer. And we end up with, at the very end of all this, 2 test words that allow seeing if it works or not. Well, they're not very significant when you look at them. R for rotary and S for switch. Do you want to see what it does? Okay.
Oh, yeah.
So this is my Mecrisp session that will run the encoder. And this is the Pi Pico session that runs the Quadrature signal generator. Now, I think if I start the T2, which is my test to generate, it's now in the loop generating a Quadrature signal. Here, if I start R, the test that shows that the rotary encoder is working, I get it started and I'll get it stopped so that you see it did count. I could switch the 2 phases around and it would count counterclockwise. I'm not going to do it because my wiring is not very stable. Okay, let's keep on going. Prove that it works on a hard HW040. I did prove it. It's there, but I realized one thing. If it's hardware, it doesn't like switch bounce. Unless you put an RC filter in front of it, it does bounce. You'll see many clockwise to counterclockwise, back to clockwise on the same, on 2 close number, like 9 to 10, back to 9, back to 10, and then 11, 12, and it goes. So it does not help correcting a problem with a bad rotary encoder. And those HW040 are awfully noisy as far as switch bounce is concerned. So it was really intended to be used with by using professional equipment like optical rotary encoders or magnetic ones. Okay, now this one might be interesting for you, because the original code for generating a Quadrature encoder was that I tried was this thing in Arduino. Okay, I tried it at work. It was too, but when looking at it, I said I can do something a lot simpler with the Pi Pico. And that's basically the drawing that I did to figure it out how to do it. See, the cycle is from here to there. I have 4 different states, 4 different time periods that are identical. So to generate a full cycle, I really have to just create the words that gives those two states to a port for 1/4 of the full cycle, and then I keep on going for each other's state. So it gave me this code here. And that's the one I'm using on the Pico. Much simpler than what the Arduino code. And all it does is basically, if you look at it now, it repeats certain state, for a pin, certain, high, low. It waits for a certain time. The next part of the cycle, again, and it goes through all four and repeats this. So that's how I generated the quadrature signal. Okay, the actual converted code, I'm giving it here, I'm not going through it, but that's the whole thing. Basically just show setting up constants for memory addresses and bit fields and how many bit shift you do and words to do it with a single word rather than collecting 3 or 4 things together. But it all ends up collected together with Mecrisp anyway, when you look at the assembly code. So that's it basically for the code. I'm not going through it. If you're interested, you get it from the Mecrisp site, or I will probably improve it, simplify it, and put it in the Forth 2020 site. But I only wanted to show you it works today. My conclusion for this presentation and experimentation is that yes, the Bluepill is capable of providing a functional hardware timer in encoder mode. So I can use a rotary, an optical rotary encoder on the Bluepill, and it generates no interrupt. It just keeps the count. So I think it will simplify the life of my friend who's trying to modify his lathe. I did understand one thing out of all this. Reference manuals are awfully complex. And I know why most people do it in software. I rarely see people using the hardware within MCUs. Well, most people are programmers and they get lost in that reference manual. But some of you are engineers and they'll be very at ease in any of those reference manuals. So it's worth using because it eliminates a whole lot of interrupts, and it makes the code more predictable, whatever else you're writing. Like my friend is losing characters when trying to send the serial data to another MCU or to his next gen. And it's all a question of too many interrupts, interrupting other interrupts, and interrupt priority. Give it to the hardware, it'll take care of the interrupts, it'll get rid of them, and just all you have to do is read a register to get the count and read another register to get the direction. So that's about it, guys. Any question?
So you use one timer per encoder?
Sorry?
Use one timer per encoder. So you're limited to
one timer per encoder, and it looks like the Bluepill is capable of doing 3 of them at the same time. Some of the encoders don't appear to have the encoder mode in the Bluepill, but in the STM32F103 family, you have some MCU devices that have 12 timers. And in that case, I would say a good 10 of them are capable of encoder mode. And by the way, they're just 16-bit timers. But normally, what you're trying to measure is the rotation of something, and in most practical cases, you don't need to go beyond half a degree. So 720 ticks will be fine for you on that clock. And it's all done by hardware, but you got to have a very clean signal. There is a little filter at the beginning of at the input of those timers, but it's only good to filter out about 16 cycles of the sampling frequency of the input. So it's in the microhertz range. So you can't filter anything beyond 1 microsecond, which is.
Have you tried it with three encoders at the same time?
No, I didn't try it. But the reason is very simple. I have a single Bluepill, and I didn't want to experiment too much. I didn't have much time to get prepared either. And I didn't want to blow it by manipulating all these little wires to get things connected everywhere. But let's say that I'm very confident that we'll do it. It's hardware. It's in there, and the hardware is just waiting for configuration to accept input signals and set registers, for the count. But I did not try more than one. This is what I'll do when I visit my friend on the 17th of June. On the nice
Fantastic,
3.Blue.
Congratulations, an excellent talk.
So, and I'm glad today we had a cold weather. Otherwise, I would feel guilty now not being outside having a beer in front of the pool.
Guess what's going to happen here in 30 minutes tops?
You'll probably have a beer. I know a few people here that like beer.
Yeah, no
Cornelius, it's time to stop recording.
Yep.
What do you think?
Absolutely.